that peaceful ending seems like a good time to get into stream. Hi everyone, it's time for your monthly dose of React Slop. I know you missed it. Well, I know some of you missed it. I guess before we get started, I have been teasing all week that there is kind of a special item I want to show off that I did actually get over my break here. So let me just say hello. It's the Just Chatting browser. Here I am. Browser, scene, alright, whatever. I'm kind of just reading words that are in front of me right now. I also need to make sure that the audio is coming over, and it is not. Okay, that's a problem. How do I make sure the audio is coming over without breaking everything? Hold on. Might as well pause this. Do that. Capture Firefox thing here. Go over to the screen layout. Gotta make sure that's not actually capturing the right thing for a second here. Sure, we'll just capture that a second time. Okay. Alright. Music's good? Music's good. Okay. Oh, music's loud. There you go, that should be good. Have fun with Costanza Plant Zone. It's actually a real banger. Anyway, so there was a chemistry thing that I've been teasing for the last several days that I did get over my little vacation hiatus there. And I did actually want to show it off today because it's relevant to the chemistry React stream. And longtime fans of me, my channel, and the Explosions and Fire channel know that carbon tetrachloride is a pretty hard chemical to actually come by, given the fact that it depletes the ozone layer really badly and also causes liver cancer, like guaranteed in like mice studies and mostly in humans too. So, the only real way you can get it as a consumer is to find a really old fire extinguisher. Because it's carbon surrounded by 4 chlorines, it is very, very unlikely to burn in oxygen. So it was used as a fire extinguisher in like the 30s to maybe the 60s before we had modern fire extinguishers with their mix of dry foam components in there that are also non-flammable. So, you know, you have Tom of Explosions and Fire had to go on a many years-long journey of thrift shopping across Australia to find a full vintage fire extinguisher that's, you know, being full over the course of decades and not piercing and not leaking, you know, or just having been open at some point to get rid of all of the nasty carbon tet inside. Extremely rare. It took him several years. I am proud to announce that it, in fact, took me one attempt. I found at a vintage, at like an antique store that me and my friends were just kind of wandering through because, you know, we were bored and we were like getting food and there was just like kind of a place nearby. There's an antique store nearby to just kind of wander into. I found me a goddamn vintage fire extinguisher from the 30s. And I was actually like telling my friends about how cool this could be to actually find, you know, out in the wild and how rare it is and like why it's so awesome. And literally within, you know, minutes of me talking about how awesome of a find this would be, I went ahead and found one. Let me just plug this in real quick. Okay, forgot something. But yeah, one, couldn't be prouder of myself for knowing and identifying like what this was and how much of a deal this is. Like, I imagine this may be a little bit more common in America than Australia, just because of the fact that, you know, what is a safety regulation in America? Especially in the 20s. There weren't, or the 30s. There weren't any. But, like, I still cannot fucking believe I found this. And, like, I was deliberating for such a long time, like, should I actually purchase this? Because, like, I could actually feel, like, that there was, in fact, like, liquid inside of there. And just to verify, I can zoom in here a little bit. You can see carbon tetrachloride. It literally is written right there. And reading the full text here basically says like it's at least 25% carbon tetrachloride. It's kind of hard to read from this picture that I took, but like, look, I'll still take 25% carbon tetrachloride. That's still a really cool find. I'm never ever going to crack this thing open. God no, I would prefer not to have liver cancer. But I will absolutely parade this thing around at any opportunity to show what an interesting find this is. If you're a chem nerd, you should obviously also be in love with this. Now, there's a caveat. I don't actually have this with me right now. So funny story is that maybe the TSA doesn't enjoy you trying to take something like this, a pressurized carcinogen bomb, through the airport security line. So I didn't do something as stupid as take it into airport security, but I did have to actually leave it with one of my friends who does like to do long cross-country drives. So at some point he will make a drive, you know, from Chicago to current location that I cannot disclose. But, you know, one day I will have this in my possession, and it will actually be something I could show off in real time and like shake around and like actually give you the sound of like, oh shit, there's actually like liquid in there. It's cool as hell. And I can show it off in my work, and it's gonna be great. And yeah, I cannot wait to have this thing actually in my hands. Like, I could also say, 65 bucks for this? Look, this has no practical use in real life, but if you know how valuable this is, if you know what's in here, this is easily worth $65, maybe more. Like, I could very much see selling this to a chemistry collector for well over $150. Like, I don't know if I would have bought it at that point for $150, but for $65, hell yeah, I'm gonna buy it. There's no way I can turn this opportunity down. So, yeah, I don't know. I'm proud of that. Hopefully y'all find it interesting too. Hopefully VOD watchers find it interesting too. But yeah, no, I just wanted to show that off. It was a highlight of my vacation away. So, with that being said, that's not what you came here for today's stream for. You came here to actually watch me do some React SLOP content and go watch NileRed's latest video on getting his latest video in his 3-part series on making alcohol from crazy shit. Which the last one in the series being the wildest, making it straight from the air. So let me do a little bit of OBS magic and actually switch us over to that window right now. Okay, I'm going to have to switch off the audio for a second, so we're not gonna hear anything. So that's gone away, and now we're gonna go over to studio mode, to screen layout. Switch that over. It's all lined up. Good. Okay. And then, there we go. Cool. A very good freeze frame of Nile we have there. But yeah, so we're, as mentioned, he's turning air into alcohol, which I have very gracefully represented with this graph of oxygen and carbon dioxide with a little bit of magic turns it into ethanol. Now I know this is not the most scientific thing in the world, but I am genuinely curious to see how he does this. You know, Nile sometimes does baffling things like dehydrate glue just so that way he can rehydrate it again. But this is one of those cases where I don't really know how this is going to shake out. I know it has to involve carbon dioxide if we're talking about the air, because, you know, we need source of carbon represented by these kind of two vertices in this ethanol molecule. And the only source of carbon that's at any consistent abundance in the air is carbon dioxide, a molecule kind of notorious for the fact that it's a bitch to try to convert into anything at scale, you know, as represented by the gestures broadly whole global warming kind of problem. I mean, you can just blow carbon dioxide into a big body of water, and yes, it will acidify the water and form carbonic acid to some extent, but outside of that, turning it into a chemical feedstock to actually make into more than one carbon molecules that contain more than one atom of carbon is not an easy feat. Typically requires really strong reducing reagents, assistance with amines, other strong bases, and that's not to say he won't make use of any of that, but it's still a pretty difficult process to do. If anything, I imagine he might try to get like some oxalic acid going, which looks like this. I haven't drawn with the tablet in a while, and I think it's probably going to show. Oxalic acid. And we'll just cram that over there. Yeah, if anything, I imagine this process might involve a little bit of this guy, the oxalic acid over here, because that is fundamentally 2 units of CO2 that are just kind of bonded from between the carbons that have also absorbed like 2 units of hydrogen, which there isn't really a lot of hydrogen in the air per se, but there is, a fair amount of water vapor, and that water vapor is H2O, has 2 hydrogens. Under basic conditions, maybe we could pluck some of that off, or maybe he's going to put it under acidic conditions to actually put the hydrogens on the CO2 itself, even though it's a poor acid. Or even though CO2 is a bad base and a mediocre acid at best. But if he does manage to get to oxalic acid, then you can kind of see, well, you already have like the 2 carbon structure down here, and you already have the 1 OH group down here. So it would kind of just be a matter of reducing off the 3 other oxygens, and then, maybe trying to just get to this 1 OH being left. Still not a very easy feat, considering how, if you look at it, oxalic acid is a symmetric molecule, so reducing one side is almost certainly going to be strong enough to reduce the other side down to just carbon-hydrogen bonds, but, chemists are a crafty bunch that have had several decades at this field. There are some reagents that can do, get just close enough in the reduction to almost reduce a molecule fully, but not quite. So, I don't know, maybe Nile breaks out the insane Sigma Aldrich chemicals and does some really cool transformations with this. My only other guess is that maybe we'll have some oxygen involved in this process, just because oxygen is another form of... Okay, oxygen gas is another form of oxygen atoms, and, maybe this process could do something where instead of taking carbon dioxide directly, it could maybe take the carbon dioxide, turn that into pure carbon, and then do something with the carbon and make those into carbon atoms into like 2 functionally 2 carbons bonded together, and then you combine that with oxygen to get some other thing, and you reduce that to get down to ethanol. I don't know. This video is an hour and a half long, so this is gonna be a fucking journey either way, but I imagine that maybe oxygen, could potentially be involved somehow. I know carbon dioxide has to be. I don't know if oxygen will be, though. But we'll find out once I stop yapping and start watching, so I think it's probably a good time to do just that thing. So without further ado, let me pause the music and get on with the show.
Over the years, I've turned many things into alcohol, like toilet paper and children's
Turn
glue.
the volume up.
And now, what I want to do next is turn air into alcohol. This is actually something that I first started thinking about all the way back in 2019.
Burning things.
When I realized that
a chemist's favorite pastime
technically contains everything that's needed to make drinkable alcohol. I mean, it of course doesn't have the typical alcohol-making ingredients like sugar and yeast, but it does have water vapor as well as CO2 gas.
Brew.
Which is theoretically more than enough.
All right, so, my theory's kind of on the way.
They contain the elements carbon, hydrogen, and oxygen, and with a bit of chemistry, it should be possible to break them apart and to then build them into a molecule of alcohol.
Man, if only it was that easy.
Or more specifically, ethanol.
Oh, shit, right. I didn't even think about the fact that, you have to actually Well, no, I did because he has put reducing agents. I was thinking that could maybe apply hydrogen to the carbons, but I mean, yeah, that's also going to be a little bit tricky too. Just getting
At
the
the
hydrogens
time,
from the
I
water onto
also
the
kind
carbon.
of became obsessed with this idea, and I really wanted to try it myself. And for some reason, I didn't think that it would be too difficult. With just a bit of
You have
research,
so much
though, I
confidence.
quickly realized that I was completely delusional and that it would, in fact, be the hardest thing that I'd ever attempted.
Just a
For
bit.
example, not only would I apparently have to build.
There's a reason that nobody has an industry that, like, you know, does this already. If it was easy, we'd all be drunk off of our asses constantly because of the abundance of alcohol everywhere all at once.
An entire gas reactor system from scratch, I would also apparently have to fill it with my own custom made catalyst and then run it at a legitimately dangerous temperature and pressure. And when I saw this, I kind of just gave up on the idea.
Doesn't want to make a bomb at home? Come
However,
on.
over the years, as I worked on other projects where I made things like purple gold, superconductors, and even my own liquid nitrogen, I slowly gained more and more experience. Then at some point, I eventually
Eventually,
felt
he
that
became a real
making
boy.
air alcohol was something that I might actually be able to do. And at the same time, I was really curious to know what it would taste like. And well, I figured there was only one way to find out. With that being said, I then just went ahead and got started, and I felt that the best first step was to put together some sort of plan. So that was what I attempted to do, and after thinking about it for a
All the best
while,
plans start in MS
this is
Paint.
what I eventually came up with. To start, I would pull water vapor and CO2 from the air, then I would electrolyze the water to make hydrogen gas, which I could then combine with the CO2 and pass as a mixture over a catalyst, and ideally, this would produce some nice and drinkable ethanol.
Good plan to start with. It's not a bad reference point. So, this okay, let me turn the music back on because this might take a little bit of time to explain and a little bit of my memory as well. So, give me a moment. Um, so like hydrogen and carbon dioxide do kind of get typically lumped together industrially in what's known as like the forming gas reaction. And hold on, let me see if I can't just like get back to maybe the relevant frame. Slow one frame advances on YouTube because 5 seconds are way too much. Alright, hold on, it'll just be messy. There we go. So like hydrogen and CO2 do kind of get the what's known as the forming gas reaction. Or not the forming gas reaction. Sorry, I'm thinking of like my job, and that's one of the terms we keep talking about. That's not the correct molecule. That's the product. It's like H2 plus CO2 can be turned into methane and water, I believe. What's this called again? Let me look that up real quick on my separate browser. H2 hydrogen plus carbon dioxide reaction. What is that called? The reverse water gas shift reaction. That's no? Hold on. I know I learned this at some point in my studies. It's just been a very long time. I guess this is called... Alright, this is the Sabatier reaction. Hold on, let me just actually look at the real link instead of the bullshit that Google AI is giving me. This is what happens when I try to make things that aren't just pure slop, when I try to actually give some context for what we're talking about instead of just going on with things. Sometimes I get off on a tangent. I'm like, wait a minute, do I actually remember my studies or am I just an idiot? Reaction, this is a low cost feedstock, this. Fischer-Tropsch process. Okay, Fischer-Tropsch is close. That's carbon monoxide and hydrogen. All right. Well, all right. I'm going to just kind of move things along here, though. One of the... So the Sabatier reaction is basically what I have written down. It'd be carbon dioxide plus 4 units of hydrogen. Ignore the bad spacing on that. Will form 1 molecule of methane and 2 molecules of water. This is one of the fundamental industrial production methods for methane gas, which is, useful for... I mean, it is natural gas. It is useful as a fuel, although usually, we actually get the natural gas that we burn for fuel, like just from mining and fracking and stuff like that, because, harvesting shit from the earth, even though it's a limited resource, is cost effective for now. This is usually used more for like producing high quality pure methane that you can use in like reactions, basically. This is all done over lots of heat, which is typically represented with a triangle. And some kind of catalyst. I believe usually this is done with like a cobalt catalyst. Hold on. Let me look this up. Catalytic reduction of all this, blah, blah, blah. Same as natural gas, used for this type of thing. So reading up on this, it's just like on, here, I could probably actually do this without too much risk to myself. So the reaction has both positive and negative aspects, resulting in limited commercial use. Is that it makes methane, and it's the same as natural gas, and can be used already in the existing infrastructure without modification of our electric grid. However, it has, methane has a higher global warming potential than carbon dioxide, so it's not exactly a green option. Then also, hydrogen gas is more expensive, and also you could just burn that directly and not make any greenhouse gases, because you just make water on combusting hydrogen. And then it's also, like, wasteful, because, like, we just fucking throw hydrogen to make water, which we do not need more water on Earth. It's a pretty abundant resource. That's funny to make, just being like, yeah, this actually sucks. Why would you ever do this reaction after I just said, oh yeah, it's so useful, we do it all the time, blah blah blah. We'll just do a control F for catalyst here though. Metal catalyst, catalyst CO2 and H2 do not react. Nickel, iron, chromium, and ruthenium are typical CO2 hydrogenation catalysts. So, yeah, back to the drawing here, we could basically then say, like, this can be done with, like, a catalyst that is nickel, iron, chromium, and ruthenium to facilitate such a thing. Now, how that works is, again, a complicated process. I don't know the exact things, and I would have to know, because it's usually not just nickel metal. It's usually, like, nickel complex with, like, some kind of, some kind of ligand, which is just, like, just to mean something that's, like, here's a bunch of organic stuff that is bound to it, and, like, this is kind of binding into the nickel, and then usually maybe there's, like, some additional things to give it some asymmetry, and asymmetry kind of breeds reactivity. So, like, I don't know, fuck it. There might be like a cyclooctadiene, aka COD, bound into this, or there could be like a carbon monoxide bound into this too, or something like that. It's a whole ass process of like finding a catalyst that might work. But that's all to say, this whole process that Nile is going through might not be a bad idea, because, this gets you pretty close. You can get a carbon feedstock this way. And as I was looking up, I found a reaction I'm less familiar with. where seems like you can actually do this kind of catalysis into methanol, which gets you pretty close. So, there's some promise in this method. Okay, that's enough diversion time for now. Back to reacting.
Gas, which I could then combine with the CO2 and pass as a mixture over a catalyst, and ideally, this would produce some nice and drinkable ethanol. I mean, this was all, of course, just a very general plan, but it at least gave me an idea of what I was gonna have to do, and I just went ahead and got started by first trying to get the air water and the air CO2.
I first tried just
I
opening my
also thought
mouth
that the
and bringing it
water
back to
would
the
be the
lab, but that
easiest to
didn't work.
get, so that was what I decided to go for first. And I figured that all I had to do was buy a generic home dehumidifier and then run it. So that was exactly what I did, and for the most part, it was as easy as I expected, and I basically just let it sit there, pulling moisture from the air and dumping all of the
I
water
do
into
love
this large
just
beaker.
like the
There was one
academic
sad and
honesty
kind
in
of
this
pathetic thing
of
about
just
this whole
like
process, though, which was that I was
harvesting
actually doing
water
all
from
of
the
this
air.
in the middle of winter
Yeah.
when humidity was already really low.
Well, also
So the process quickly.
also Nile, just the fact that like there's literally just snow outside, and like arguably that is from the air, right? Like snow did originate from the atmosphere, so you could argue that that is, making alcohol from the air, but because you're so pure about this, it's like, no, only the actual air. I must get a fucking dehumidifier specifically to get water, probably the most abundant solvent you could ask for.
Became painfully slow, and it only got slower and slower as it squeezed out the very little water that was even there. This, in turn, also caused the humidity in my lab to just keep getting lower and lower. And nearly a month later,
Also,
when
I'm
I
just
finally
realizing
had the 1600
that
mils that I
little white
wanted,
tangent of
my
his that
lab
was
was
from
so
January
dry
2023.
that it might have
3
actually
years.
been bad for my health. But either way, with all of that thankfully done and over with, I just took all of this nasty air water and I quickly cleaned it up
Nasty air
by first
water.
pouring all
What?
of it into a cheap water boiler. I then added the top part along with a beaker, and after turning on the power, it wasn't long before some nice pure air water started distilling over, and I waited for it all to eventually
Congrats, it
make
looks
it.
about the same.
Then after that, I transferred all of this beautiful air juice to a nice glass bottle, and for the time being, I temporarily put it
With
aside
no labeling.
because what I had to do now was move on to the other main
In 3
ingredient,
years, he comes back and
which
is
was
like,
the
is this, what the fuck is
CO2.
this? Sulfuric acid?
For the
Let me just give it a
CO2,
taste.
though, I knew that it was going to be a lot more difficult to get than the water, and this was mostly because A, there just isn't that much CO2 in the air to even extract, and B, selectively pulling it out and isolating it is not nearly as straightforward. However, after doing a lot of research into every single CO2 capture method
I'm
that I was able to find, I eventually came up with a decent plan that I felt would work.
simply going to just steal an industrial CO2 harvester.
I then almost immediately got started with it by first getting my huge container of generic sodium hydroxide
Yep,
drain cleaner
that's
and
typically the
by
best way
pouring
to
a bunch
start
of
at
it
home.
into a large glass dish.
Just gonna etch the
Then,
glass
after
there.
spreading it
That
out
doesn't seem
and
like good
making
for the
it as
glass.
even as possible, I just let it sit there and I waited for it to start pulling moisture from the air.
Yep.
It also shouldn't have had a problem doing this because sodium hydroxide is extremely hygroscopic, and I was very happy when it only took a couple of days for the entire thing to liquefy into a goopy mess.
Ooh.
At this point, though, I should say that waiting for all of the water to come from the air was mostly just out of convenience, and I definitely could have added it myself. But regardless of that, what I had now was an extremely concentrated soup of sodium hydroxide, and at least in theory, it should have been able to do something very important, which was slowly absorb CO2 from the air. What I mean by this is that as it just sat there, CO2 in the air should have been slowly and passively dissolving into the water and then almost immediately reacting with the sodium hydroxide to form sodium carbonate.
Yep.
This in turn should have caused there to be a
I drew
constant
it
flux of
strangely,
CO2
but
coming in and getting converted to sodium carbonate, and basically,
this liquid should have been able to continually suck CO2 from the air. The very important trick here,
Yes,
though,
it's
was that none of this
to explain to you the chemistry that's going on here. The reason that this works is because the carbon dioxide, CO2. That's certainly a way to try drawing this. Um, is that the oxygen being strongly electronegative on the periodic table is pulling electron density away from the carbon. So you end up having an electron density that represented by deltas in how much charge is kind of like relatively at each position. You have a relatively negative charged oxygens with a relatively positive charged carbon. And then if you have a hydroxide anion, looks something like this with electrons being represented as dots, negative charge here. That's just a flat out real negative charge. There's a real difference of one, negative charge unit, electron versus a protons in the system. Um, those electrons being negative attracted to the positive carbon that would knock over these electrons to the oxygen. It gets what it's trying to steal and suck away anyhow, and then that forms the carbonate anion. Looks something like this. COH minus, and then CO. This has a minus on it. 2 minus up here. I should draw that real quick. And then given that this is a basic solution, the H kind of gets stripped off by yet another hydroxide kind of in solution. So that just steals this right on over, and then we get a carbonate anion. So that's why this works. You can just simply leave out your sodium hydroxide and completely fucking ruin it and turn it into sodium bicarbonate, baking soda. Uh, so don't do that. And unless you're trying to make alcohol from the air, I guess.
CO2 was truly being destroyed, and it could all be easily released from the sodium carbonate whenever I needed it, and this will all make a lot more sense later on. But with that being said, I then just let it sit there and I occasionally stirred it, and as more CO2 was captured, more sodium carbonate formed, and it was all supposed to slowly solidify.
Also, slowly
The
destroying
only
your glass
unfortunate
dish.
part was that just like getting the water, this whole process ended up being excruciatingly slow, and after a couple weeks, I genuinely
That's
started
getting
worrying
chonky.
that it was
So weird.
never going to be done. However, that thankfully wasn't the case because over the next 2 weeks, it did slowly dry up, and eventually, I was left with some nice and crispy sounding sodium carbonate, which was exactly what I was hoping for.
That is still so cool to me how like it does go from being, completely nice little solid pellets of sodium hydroxide to soupy goopy caustic mess to dry sodium carbonate. And it's just kind of because sodium carbonate um sodium carbonate does hold on to water, but not nearly as much as sodium hydroxide does. The sodium hydroxide is a lot more basic. It's a lot more ready to kind of attack water and hold it as part of its crystal structure. It also kind of crystallizes with it better because it's literally just one hydrogen short of being water. Um, so like but then once it reacts with carbon dioxide, that's kind of a neutralization reaction. It forms a weaker base. That weaker base is not really able to attack the hydrogens on water vapor as much anymore. And so most of the water vapor just evaporates, gets released, and, it ends up drying up again. And it's kind of really interesting too that you have like that medium spot where the sodium hydroxide is essentially dissolving itself using just water from the air. Because without that, this process would be even slower than the like 2 or 3 weeks he had to wait because solids don't really react well with anything else just because like they're not very mobile. Solids are solid. They're not flowing around each other constantly. Once it dissolves in a liquid, the sodium hydroxide, then it's a lot easier for it to interact with the CO2 gas and form carbonate.
Which was exactly what I was hoping for. At this point, I was also very relieved to finally be done with this horribly inefficient process, and I was
Sounds like
pretty happy
glass.
with how much I seemed to have made, because it was quite a bit, and it was apparently about 2,100 grams. This in turn meant that I'd
Two
potentially captured
kilograms? God
around
damn.
850 grams, or about 2 pounds of CO2 from the air, which I felt was kind of impressive, and as far as I could tell, this was more than enough for the entire project.
I don't know how pure
But
it
anyway,
actually is,
with all of
but,
this
you know,
powder and
good
air
estimate.
water now in hand, I was ready to move on to the next
Congratulations, you can
step,
now make a baking
which
soda
was to figure
solution.
out exactly how I was going to be using this stuff to make the ethanol. I mean, I knew that I was going to be electrolyzing the water to make hydrogen gas and using the sodium carbonate to make CO2, and then combining and reacting these gases over a special ethanol making catalyst. But that was just a very
Yeah, the
simplified
catalyst
plan,
is kind
and
of the
as I
linchpin in
mentioned
all
earlier,
this.
to actually do this in real life, it would be way more complicated, and it was going to require things like an entire.
Also, hold on. Sorry. Oof. Getting desperate enough to reference a doctoral thesis up here in the upper corner. That's rough. Not only is it because a doctoral thesis like takes or is usually several hundred pages in length and is just a poor grad student documenting basically literally everything they did during grad school and maybe a good couple of tens of pages of like reference material that supports, you know, the history of their work and why their work is justified as potentially working. Um, you have to be pretty fucking desperate to actually reference a doctoral thesis, in my opinion. Especially because usually doctoral theses work is often just published in much more concise and better formatted articles rather than, you know, a several hundred page manifesto. Ugh.
Real life, it would be way more complicated, and it was going to require things like an entire gas reactor system and a very special catalyst.
Buy all that.
I was also
You're
going to have to
rich.
make
Big
all of
YouTuber
this
man.
myself because both of these things were basically impossible to buy and
What?
they had to be fully custom,
No.
and this was quite daunting to say the least. For some reason, though, I still had faith that I could do it, and from what I could tell, it seemed like putting together the reactor system was going to be a little less painful than making the catalyst.
All right. Something that only a fucking chemical engineer would say, because Nile has said before he never actually got a chemistry degree. He got like a chemical engineering degree, I remember. If I remember correctly, that it was like just some other kind of science engineering. An actual chemist would never say, "Oh yeah, I could just easily throw together a fucking reactor." That's less difficult than making a new catalyst. Sure. Sure, buddy.
So I decided to focus on that first, and I ended up
It's
spending the next
impressive.
few
I would just
weeks
never think
just
that.
doing research and trying to figure out how high temperature and high pressure reactor systems even worked. Then, when I felt that I had a decent idea, I moved on to the next very important part, which was to put together my own design, and this turned out to be quite difficult for many reasons.
Yee, play with the
However, the
icon.
main one was that whatever I came up with had to be fully compatible with hydrogen gas, which was not only extremely flammable
Yeah, it's a
and
toughie.
potentially explosive, it was also capable of something called embrittlement.
And leaks everywhere
What I
too.
mean by this is that since hydrogen is such a small element, it's actually able to diffuse into many metals and to slip in between the spaces of their atoms. This in turn can cause the metal to become brittle and to potentially break catastrophically, which is especially dangerous when working at a high temperature and pressure.
If you're maybe curious as to why hydrogen slipping in kind of weakens the metal structure, you can kind of think of it. It's not exactly like it. It's actually kind of in the opposite direction electronically, but it's kind of like oxidation. So it's kind of like how rust is just a much weaker and more brittle material than just like say regular iron or steel is. And that just has to do with the fact that it's no longer a metal material at that point anymore. Metal oxides are um, ionic in character. You have iron ions and oxygen ions, and I guess in this case, sort of hydride ions. Um, and just at that point, the kind of individual character of like, oh well, these are hard, discrete units of charge separated that are kind of like forming a structure of like alternating, repeating units. In this case, it's not quite exactly that, but you still kind of get some of that more charge separation. The ions don't become as identical to each other anymore, and the whole thing just gets a lot less flexible because you have hydrogens kind of like being like, well, no, I'm here. You have to bind around me. And it's just not really, you know, quite as quality metal anymore. It's still metal, but it has defects, and that leads to problems.
And the scariest part is that there is technically no way to fully prevent this, but there are some alloys like brass and 316 stainless steel which are much more resistant. So that's what I was going to have to use to build the system, and at the same time, I was going to have to make sure that all of the internal parts of every piece were compatible with hydrogen as well.
Good job, Niall.
Also,
You're doing a much better job at your own safety precautions than the fucking grad students that I work with. But that's something for
on
another
top of
day.
that time, I was going to have to make sure that all of the internal parts of every piece were compatible with hydrogen as well. Also, on top of that, there was one other major thing that I had to consider, which was that this process would produce a decent amount of extremely
Oh, that's
toxic
great.
carbon monoxide, and I would, of course, have to safely deal with that. With all of this in mind, though,
I'm a little curious where the carbon monoxide comes from in this, but I guess he's only kind of half doing stuff, or maybe he's making carbon monoxide as an intermediary to form the ethanol. I don't know. He hasn't laid out his grand reaction plan yet,
I
and
did
I can't
eventually
predict
put
it.
together a design that I felt would work, and I spent the next few months just buying all of the things that I was going to need.
Pilfering hardware
For
stores.
example, I got a bunch of stuff like some gas cylinders and something called a gas booster, as well as some two-stage regulators and a hydrogen generator, and a lot of other random parts and pieces.
Oh no, never
Then, when
mind. I
I
was going to say a hydrogen generator. That's cheating, but no, it's probably just you pour water in and then it electrolyzes it.
eventually had everything, I started putting it all together, and well, long story short, it turned out that my initial design kind of sucked, and I ended up running into at least a few critical issues. I also ended up spending a ridiculous amount of time dealing with what felt like a never ending stream of little problems that just kept popping up, and I definitely bought way too many things
You
in my sad struggle to fix them.
could build a small
But
power
I guess
plant
this
with all
all
that.
should have been kind of expected because I wasn't exactly an expert with any of this, and this was by far the most complicated thing that I had ever attempted.
Yeah, bang that shit
After
on the
several
desk.
painful weeks, though, I finally had something that I was reasonably confident would work, and I went ahead and built an entire wall behind it just to give it a nice white background. Then, with all of
Okay,
that in
fair. That's
place,
dedication. I
this
can
was the
respect that.
final result, and in my opinion, it was one of the
First, I thought he was
coolest
erecting like a
and
black
most
a
impressive
blast
things that I had
shield.
ever built. It was also a lot simpler looking than I ever thought it would be, and this was mostly because I spent a long time trying to make sure that it would be nice and
All
presentable.
right. Yeah.
But either way,
Props.
overall, I was very
Props to Nile
happy with
here.
how it all turned out.
I cannot say that I have ever built a fucking gas contraption like this. I do not have those kinds of talents. This is when you are a chemistry student, you are taught how to do things with glassware the way that professors have been doing since like the 1960s. And maybe you get some new pieces of glassware that were invented in the last couple decades, but you only engage in bootleg engineering. You put pieces of glass together with like tubes and copper wire and like, tape and shit like that. You don't actually break out real metal to metal contacts and make like authentic piping. You just kind of bootleg it until it works. This is very impressive.
Out, and I was really excited to actually use it, except unfortunately, that wasn't something I'd be able to do for a while. This was
No.
because at this point, there was, of course, one extremely important thing that I still had to do, which was to make the special ethanol producing
Ah,
catalyst
yes.
and to load it into the reactor over here. So that was, of course, what I was going to have to do next, and I just went ahead and got started with it by first doing a bit more research to try and figure out exactly which catalyst I was going to be making. I then spent a very long
Time
time
for metal
analyzing
soup.
the ridiculous number of options that I ended up finding, and I attempted to single out what I felt would be the best one, except, long story short, it turned out that they were all kind of bad.
Yeah,
What
there's
I
a
mean
reason we
by
don't do
this is
this.
that in general, none of them were very efficient, and on top of that, a lot of them had some other major downsides, like being extremely expensive or very difficult to make, or even a combination of the two. This also, unfortunately, wasn't too surprising, especially considering that even now, the direct conversion of hydrogen and CO2 to ethanol is still a relatively new field of research.
Yeah, it
That
doesn't
said,
even have like the big bucks associated with it either. Like, sure, we all love to consume a lot of ethanol as consumers, but you know what consumes a lot more carbon by mass? Industry. If you can make carbon dioxide into other feedstocks, then that's industry money there, baby. That's billions of dollars, perhaps trillions.
I did eventually stumble onto this paper, which I thought looked super promising, because the catalyst that they made seemed to be exactly what I was looking for. And by that, I mean that it was one of the most efficient ones that I was able to find, and on top of that,
Efficient at
it was
12%. It's
relatively
bleak.
inexpensive. The only slight catch was that it was a two-part catalyst with a so called CZA portion as well as an iron based portion, which meant that it would be a bit more complicated to make. However, after reaching out to the first author of the paper and asking a bunch of questions,
Let me see what some of these questions. What's the largest scale you tried this on? I would like to try it and make 50 milliliters of ethanol from this. Do you think it's feasible? Do you think this would work at 50 psi? Or is high pressure 5 megapascals necessary? Yikes. Or did you try chance low pressure? Do you remember what machine method you used to actually get this correct composition? Similar procedure? Oh boy. Well, glad it seems like you actually got response from the first author. That can be hard sometimes.
I was pretty confident that it wouldn't be too bad. So I kind of just decided to go for it, and at the same time, I figured that the best place to start was with the iron based portion of the catalyst. This was because, at least based on the procedure in the paper, it seemed like it was going to be the hardest part, and I liked the idea of
Let's see. Iron-based catalyst, iron at carbon, was obtained by pyrolyzing the iron metal organic frameworks at 550 C for 3 hours under nitrogen atmosphere. Iron moths were prepared by the hydrothermal method. Okay. Since this isn't a moth video and we're already kind of running into an hour on time, I'm not going to go into the entire description again of what a moth is. I've explained this in a previous video. But to put it shortly, a moth or a metal organic framework is when you have ions. All right, maybe I'll do a little bit of drawing. You have metal ions of some kind, in this case, iron, and then you have ligands that are bound to it. Usually some kind of carbon based ligand, but or we call them linkers because they are going to link um, multiple multiple metal centers together. So a very oversimplified design for a moth could be something like this, where you have this kind of carboxylate organic connecting irons together, and then this repeats, ad nauseum to connect more irons together, and you have this full three-dimensional structure of carbon of organic stuff and metal stuff forming a framework, hence the name. So pyrolyzing it means making this and then burning it, so that way all the organic shit or most of it leaves. Which that's a very complicated way of making something. But the point of making the moth first is to get the structure you want, and structure in chemistry dictates reactivity. So you make a moth. in what's called the hydrothermal method, which is basically just putting a bunch of stuff in solution, heating it up, and then cooling it down and seeing like what crystals you get. Um, so you make that first to get your basic structure, then you burn it to get your exact structure, and you're doing it under nitrogen atmosphere, as it says over here. You're not introducing extra oxygen, so you're not just burning it down to rust. You might still have a little bit of carbon incorporated based on like whatever the chemistry, the precise chemistry taking place is. And so they're getting some kind of iron at carbon catalyst, which I'm guessing is probably literally some kind of like iron carbide like structure where you actually have, this is almost certainly a gross oversimplification, but you have an iron carbide kind of thing going on here where you have irons probably interspersed with carbons. This is kind of how steel works, although carbons are not nearly as interspersed in steel. So having a much more balanced amount of carbon versus iron in almost like 1-to-1 ratio, hypothetically, that's kind of what the picture looked like before. I don't know. That could have some kind of crazy catalytic properties. It's a little bit out of my ballpark of my field of study, but that's kind of essentially what we're going for here. But then yeah, they're basically saying they would mix iron chloride with their linker, this triethylene diamine, then into some DMF for some solvent, with a little bit of a benzene dicarboxylic acid, kind of like the thing that I drew here. Adding it in, stirring it for a while. Um, do, 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 do. Then transfer it into a Teflon lined autoclave. An autoclave. That's usually like just a steam bath kind of things to kill bacteria when you're like trying to clean stuff. Whatever. Anyways, I'll move on from that. Solid products, followed by this, washing it with more DMF, putting in a vacuum. Sodium iron at carbon was prepared by a wetness impregnation method with sodium carbonate as a sodium resource. Sodium carbonate in this was characterized by this. Okay, I have no fucking clue what wetness impregnation method means, but they get their burnt iron carbon thing and then they throw sodium carbonate at it and they get something. So yeah, that does seem pretty fucking complicated, especially keeping something baking at 550 C under nitrogen atmosphere. It is hard to keep a furnace like that airtight and also and keep it under nitrogen at the same time. That's some specialized equipment right there.
Dealing with it first, and after going over things a few times, I found that there were going to be three major steps. The first was to make something called an iron metal organic framework, or iron MOF for short. The second was to basically burn it and to turn it into something the paper referred to as iron at carbon. And then the third was to coat this with sodium ions to make the final catalyst
Way ahead of you,
called
Nile.
2%
Already
sodium
explained it.
iron at carbon. Overall, I had to admit that altogether this did sound like a lot of work, especially considering that I was going to be massively scaling up the original procedure, but at the same time, I
By
still
6.
didn't feel like it would be too bad. So I just went ahead and got started with it by first getting a flask and by adding 300 mils of a solvent called dimethylformamide,
This stuff
or
stinks like
DMF for
fish. It's
short.
gross.
Then into
It is
this, I
thick and
quickly added
oily, and it
3.6 grams
coats the
of
entire
iron
room with a
chloride
terrible smell.
tetrahydrate, which almost immediately started dissolving and forming some nice colored complexes with the DMF. And after letting it sit there for a bit, I turned on the stirring. This caused the solution to quickly become an even darker orange and for it to slowly get darker and darker. And once it had completely dissolved, I
Slow
quickly
motion.
added the next ingredient, which was something called triethylene diamine, also known
Dabco.
as DABCO. Like the iron chloride, this caused a nice and strong color change, and what should have been happening here was a reaction between the DMF iron chloride complexes that I just made and the DABCO. As far as I know, this was leading to the formation of a bunch of different intermediates,
Dabco is essentially
where the
this
major one
two
was probably
nitrogens
some so-called
bridged by
hydroxyl
some
iron species. It
3
was going to take at least a few
carbon
minutes for it to all
ethylene
react, though,
moieties.
so in the meantime, I went and got my addition funnel, and I added it to the top of the flask. With that in place, I was then able to add a nice and clear solution that I'd made by dissolving a small amount of terephthalic acid in about 70 mils of DMF. And when I was done with that, I looked back at the reaction and it seemed good to go.
Still seems brown,
So
yep.
I carefully opened the funnel. This caused the solution to be let out really slowly, and my goal was to add it all dropwise, and this time, there wasn't an immediate color change or anything. In theory, though, the terephthalic acid was supposed to be reacting with my mixture of random intermediates and leading to the formation of a new complex that's generally referred to as an Fe3O trimer. However, these trimers wouldn't stay on their own for very long because they were all supposed to continue reacting with the terephthalic acid to form intermediate molecules that could then combine with each other. This in turn was supposed to lead to the formation of a massive and
Yep.
highly ordered
There's a good
structure
diagram of a moth.
that would be held together by strong bonds between the iron
And
terephthalic
Dabco
acid,
filling these
and in general,
holes for
this
some
is
reason.
known as a metal organic framework, or MOF for short. But anyway, once it was all added, I transferred it all to a Teflon container, and after sealing it, I dropped the entire thing into a large stainless steel pressure chamber. This was because most of the reaction that I just mentioned wasn't really going to be able to happen at room temperature, and in order to actually make them off and to have it form with the proper crystalline structure,
Oh boy.
I was going to have to heat it up under pressure.
Well,
So that was exactly
you already
what
built
I
one
did
big
by
pressure
just putting
reactor,
the
might as well make
entire thing
another.
in my oven that I had preheated to 120°C, and after leaving it there for about 24 hours, I took it all apart and I pulled out the Teflon container. I then quickly popped it open, and the first thing that I noticed was that the color was way brighter
Tasty.
than before. And in my opinion, it kind of just looked like some generic paint. But as far as I
Oh,
can tell,
this juice is
this
banging.
was
It's paint,
exactly what I was
asshole.
looking for, and what I had now should
Oh,
have
now
been
it's just dark
a bunch
urine.
of MOF
Ew,
floating
chunks.
around in a soup of DMF, along with a bunch of other random side products. I, of course, only wanted the MOF, though, and the rest of the stuff was just trash. So what I was going to have to do next was purify it out, and I was honestly a bit worried that this was going to be a huge pain.
Another thing worth
But
noting, MOF
despite that,
syntheses
I
typically
just
aren't
went ahead and
very
got started,
efficient.
and well,
Usually you
for the
get
most
yields
part,
like in the
it actually ended
40%
up being
range.
relatively simple.
So
And by that, I mean that
might look like a
basically
lot of
all I
product.
ended up
Oh,
doing
it's
was
less.
just centrifuging it to push all of the MOF to the bottom of the container, which allowed me to easily get rid of the dirty DMF. Then after that, I was able to clean it up even more by washing it with some fresh DMF and by using the centrifuge again.
I still
to
do find
knock
it amazing
everything
that
to the bottom.
centrifuges can just be like, yep,
I
I'm
also
going to
ended up
spin something
repeating this
so
cycle a
fast that
few
the
more
dense
times
materials just
just
form a
to
nice
really make
cake
sure
at the
that it was
bottom
all
rather
clean.
than floating
And when I was
everywhere.
eventually done with that,
Look,
I
it
put
just
it all
fucking
into
stays
my
at the bottom of
vacuum
the
oven.
plastic. It's not being held by anything like chemical, just
This was
physically
because I
stuck
wanted
there.
to get rid of any remaining DMF and to dry it as much as possible, and a few days later, this was what I was eventually left with. Just a nice pile of dry and crunchy powder, which should have been
Yeah, it looks like
really
clay.
pure iron-based MOF, and with this now in hand,
Can we get 3
I
cheers
was
in the chat
feeling
for
pretty
clay?
good. At this point, I was also officially done step 1 of this catalyst, and I could now move on to step 2,
Hopefully you
which
are.
was to basically burn
We have no
everything that I had just
characterization methods
made
to prove that you
and
made
to
them off.
turn it into iron at carbon. So
I mean, I'm
that
sure
was
you
what I
do, but maybe you
immediately
didn't show
started
it.
working
So
on next, and the first thing that I did was quickly put together this little setup.
tube
Where
furnace, the
over
bane
here
of my
I had a
existence at
high
work.
purity nitrogen tank that would allow me to flow nitrogen gas out of this black tube and into this flow meter, and then into this tube furnace. At the same time, I also had this vacuum pump that was connected to the same end of the tube furnace, and this will all hopefully make a lot more sense in a few minutes. But with that being said, I then just got started with things by first transferring all of my powder to an alumina boat. I then slid it into the quartz tube that was sitting inside the tube furnace,
Not gonna crunch it
and
up
after loading
first?
in
Make a powder
another
out of it?
alumina plug and
That
sealing the
would give
open
higher
end,
surface area. You
I
get a better
flipped on my
reaction.
vacuum pump. This caused all of the air in the tube to get sucked out, and once I saw that I had a nice stable vacuum, I closed the valve to the pump, and I refilled the tube with some high purity nitrogen gas. Then, after repeating this process 2 more times, just to make sure that there was only nitrogen in there and effectively no oxygen, I opened the valve on the end of the tube so that nitrogen could flow through it, and I carefully adjusted the flow rate to 500 mils a minute.
Hmm.
With all of that done, though, it basically should have been good to go, and at this point, I was feeling pretty good about things. So I just went ahead and flipped on the heating to start the whole cooking process, and the goal now was to slowly raise the temperature at a nice and steady rate of only 2 degrees per minute. It was also going to have to go all the way up to 550 C, which meant that this was going to take a while, and for the first couple of hours, not too much happened. However, when it eventually got to around 200 C, I started to see some smoke coming out with the nitrogen, and as it continued getting hotter and
Take a rip
hotter,
off that hot
it
blunt.
slowly got smokier.
And we lost OBS for a second. Oh, but we're okay. All right, that was very intermittent. Maybe that was just a freak accident. I did get that new Ethernet cable in, so hopefully we shouldn't be having too many interruptions like that in the future.
Air was actually burning. This was because, with no oxygen
Haven't had
present,
problems
it
yet,
would
so
be
this might be the first.
impossible to burn, and instead, it all should have been gently breaking down through a process called pyrolysis.
Look, nothing gently
More
breaks down
specifically,
at
the moth
500
should have
C.
been slowly decomposing and turning into gases like carbon monoxide, hydrogen, methane, and CO2,
That's probably what it's
which
doing,
was
yeah.
all getting carried out of the tube
I
by the
guess
nitrogen.
maybe it shouldn't look smoky,
Left
but
behind, though, would hopefully be a bunch of carbon in the form of charcoal, which is basically the stuff that's found at the bottom of a fire, and this probably doesn't sound too special. But in this case, it
it's
would
charcoal
be, because it
impregnated
would
with
all be
iron.
coming from the iron-based moth, which has a unique and highly ordered structure with a very specific arrangement of iron atoms. This in turn was supposed to result in a highly porous charcoal that was filled with an extremely even dispersion of iron-based nanoparticles, and this was what the paper referred to as iron at carbon. But anyway,
Yeah,
as it continued
nanoparticle
getting
synthesis
hotter,
people
the
are
amount of
crazy.
smoke
I don't
gradually
understand
got
how they
less and
can have
less,
that fine
and by the
tuning
time
of
that it got to my
molecules,
target
but
temperature of
good for them.
550 C,
They make
there
industrially
was
relevant
barely any
things.
coming out. Then, as I
I just
continued
toyed around
heating
with
it,
shit
the
that would never
smoke
see
only
practical
continued
use.
to decrease until a few hours later, when it eventually stopped coming out at all. And at this point,
It's done.
everything in there should have been fully degraded. So what I did next was just turn off the heating, and I waited for the entire oven to cool down. And when it eventually got to a reasonably low temperature, I just went ahead and opened it up. What I then saw was that everything had become completely black, which was exactly what I wanted,
Yeah.
and it was definitely very different than the nice salmon-colored stuff that I'd put in.
Salmon?
As far as I could tell,
Whatever.
it
I don't have
also
time to
looked
litigate
like it had
colors.
been fully carbonized, meaning that what I had now should have been just a bunch of carbon filled with a fine dispersion of iron nanoparticles, and overall, I was pretty happy with how it all turned out. The only
Say it
slightly concerning part was that upon closer inspection,
didn't really break
I
down
did
that
notice that there
much.
was actually some red color in a few places,
Hey, I
which
would
at
maybe
first
grind that a
I
little
thought
bit and
might
try it
have been some
again,
stuff that
Nile.
didn't break down. Then on top of that, I also noticed that everything that I had was actually brown and not black, like pure carbon should have been.
I mean,
However,
you're
after
not going
looking
for
back at the
pure
paper,
carbon.
I quickly realized that this made a lot of sense because it clearly stated that a lot of the iron was supposed to be turning into iron 2 oxide, which is brown. Also, for the small amount of red stuff, I came to the conclusion that it was likely just due to a bit of oxygen contamination.
It
And as
still
far
looks
as I could
brown to me.
tell, at this point, step 2 was now done, and with only one step left, I was already getting really close to having my finished iron-based catalyst,
Oh, Nile, you
and
have
so
so much
far,
confidence
I'd
in
basically run
what you've
into no
done
real
that
problems.
it hasn't,
I
like,
mean,
you know,
that
been
wasn't until
wrong.
I weighed it and I saw that what I'd made was only 1.8 grams, which was way less than I ever imagined I would get from this, especially because I had already
Could have
scaled up
been
this
doing some
reaction by
characterization
6
steps on the
times.
way here.
The final step wasn't going to add any real mass to this either, which meant that 1.8 grams was the max that I was going to get, and this was more than just a little concerning.
Is this
This was
like a
because,
6%
based on
yield?
my calculations, I was going to need at least 25 grams of it to make ethanol at a decent rate,
Yeah, so like
and to
that's,
get that,
yeah.
I would apparently have to repeat the entire process 13 more times.
And that's
And
assuming you
considering
have
that
the
what I had
actual
just
thing you
done
need.
had taken about 5 days, I was potentially looking at up to 65 days of work. Just thinking about that kind of hurt my head though, and at this point, I was extremely tempted to just quit on this catalyst.
Ah, come on,
However,
Niall.
at the
You said
same
that about
time,
so
I
many things and
still
you haven't
felt that
gave
there
up.
was some hope, and after thinking about it for a bit, I was pretty convinced that all I had to do to get through this was just scale things up even more. From what I could tell, there was
Fuck
also
it.
only
Just
one
assume you're
major
doing it right and
bottleneck that
plow
was stopping
forward.
me from doing this, which was the stainless steel pressure
Now,
chamber,
that's the best
and it
quality of a
seemed like all I
scientist.
had to
Don't
do
check
was
your
buy a
methods and
massive
don't
one.
check your stuff ever.
So I just hopped
Just
onto
fucking go
Alibaba,
for it
and
and hope
after
that it
searching
works in the
around for a
end.
bit, I ended up buying this
You
one,
assert your
which
chemical
was the biggest
confidence.
one that I could get before the price skyrocketed and
To be
became
fair, I don't really
completely
know how he would
unreasonable.
actually be
Then, when it
testing the
eventually
composition
arrived
and
a few
structure of
weeks
this, but
later, I
I don't know.
just jumped right
Surprised he
back
hasn't
into
purchased
things
like a
by
X-ray
basically
crystallography
doing the
instrument
exact
yet.
same process all over again, except on a much bigger
You
scale.
know, he could probably do some kind
At
of
the
X-ray
beginning,
diffraction and be
everything
like, oh, this
also
is the
seemed to
iron
go
thing, and match
totally
it with the
fine,
pattern
and
in the
with step
supplemental
one,
data from the
the
paper, and
only
blah, blah,
issues that I
blah.
ran into
You
were
could
some
do that.
slightly
I'm
annoying
sure he has
things,
some reason to buy
like the fact that
X-ray
the new
equipment.
reactor was way heavier than the other one, and once it was loaded up with the entire reaction mixture, it weighed
I mean,
around
hell, he has the
80
money to spend
pounds.
on this shit.
This made it a pretty painful process to get it both in and out of the oven,
Yeah,
and
Nigel,
to
you
move
should
it
maybe get
around in
forklift
general,
certified to be
and I
moving this
even had
shit.
to reinforce the rails in the oven to prevent them from breaking. On top of that, having to deal with so much more product made the centrifuging and cleaning steps a lot more tedious, and I ended up having to get my rotovap going just to deal with all of the extra solvent. However, all of that turned out to be very pleasant
Oh,
compared
that's
to
a
what
different
came
looking kind of
next
color.
with step
That's
2,
more like
when I
rocky.
realized that I'd somehow completely forgotten that I could only load one boat at a time into my tube furnace.
Oops.
This meant that the whole process still had one major bottleneck, and
And
I have
solve that
no
bottleneck by
idea
buying a
how this
bigger tube
completely
furnace.
slipped my mind. Regardless of that, though, I ended up deciding to just power through it instead of trying to buy a bigger tube furnace or something,
Ah,
and
he
let's
considered
just
it though.
say that it was pretty painful. This was because, with one boat at a time, I ended up having to repeat the process 14 times, and considering that each run took a full day, this was basically all I did for 2 weeks. What also made things extra fun was that at the same time, I had to keep repeating step 1 so that I would have moths ready to continually load into the oven, and pretty much the entire time that I was doing this, I was kind of wishing that I had just given up. But either way, in the end, when I did eventually finish, the final result was 4 separate jars with about 6 grams of iron at carbon in each one, and at this point,
Hopefully.
I was honestly so beyond done with this process. However, on the bright side, in total, I somehow ended up with exactly 25 grams, which was suspiciously convenient, and now, with step 2 officially
No, Niall, it
completed,
just means that you're
I
really,
was
really
super
good at
close to
chemistry.
finally being done with this
When you
catalyst.
can just eyeball
As
something and
far as I
measure
could
it
tell,
perfectly,
it
or like
also
get the
seemed like
exact
the
feel you
last
needed,
step
that means that
was
you're just a pro.
actually going to be really easy because I just
Take
had
it
to add
from a
some
pro.
sodium ions to what I already had, and according to the paper, all I had to do was a process called wetness impregnation.
Yeah, well, so what the hell
The
does
only
that mean?
slightly tricky part was that I'd honestly never heard of that before, and when I Googled it, I was only able to find
When
very
I Googled
general
it, I
information
was met
about it,
with a
so
message about safe search. Do you want to turn this off?
not exactly how to do it. After looking around forever, though, and watching every random video that I could find, I eventually felt that I knew how to do it myself. So I just went ahead and got started by getting that first small batch that I'd made and by dumping it all into a bowl. And on top of this, I quickly added all of the stuff that I had in the jars,
Yeah, put
which
all your eggs
all
in one
together
basket.
now gave me a total of
This could not end
26.8
horribly.
grams. And after stirring it around a lot to make sure that it was fully mixed, I transferred a
But
small
chemists
amount
do
of
this
it to a
shit too, so.
dish.
Yeah, hey, Chris.
I then
Nice to see
very
you here.
slowly and dropwise
We're,
started adding
in
a solution
case
of
you
ethanol.
need some context, we're watching NileRed turn air into drinkable ethanol. And this is a crazy multi-step process he's going through, but his basic idea is to, well, it's not that what I had drawn up there. His basic idea is, yeah, I don't have any great drawings for this. His basic idea is to he got water from, the water vapor in the air. He got carbon dioxide from the carbon dioxide in the air, and he needs to use a very complicated pressure setup, which he built himself. He found the engineering part of this easier than the chemistry part of this, funnily enough. Um, and now he's trying to make some elaborate iron catalyst, two-part catalyst that he found in a paper that should help him do this. He's making the first part of the catalyst, this elaborate iron, carbon, sodium kind of mixture, and we're right in the middle of that step. So it is weird, and we're doing a process called wetness impregnation, and I don't know what that means, and it does not sound comfortable.
In water, and the goal here was pretty simple. All I had to do was carefully add the solution with a lot of mixing in between the additions and to go just until the point that it started clumping. Because
Okay.
at this point, it would mean that the powder was at its limit of what it could absorb. And when I eventually saw this happening, I wrote down exactly how much liquid was used.
So wetness impregnation is apparently a technique where you literally just put enough solution into something until it is like fully um saturated with it without dissolving. Like it's basically, what you would do to like a rag. You would like immerse a rag in water and like, oh look, it is now fully damp. Congrats. This is the wetness impregnation. I guess that makes sense. It just sounds like a bit of a haughty term for something so simple.
Then after that, I repeated this 2 more times,
Well, it doesn't
with
exactly sound
each
haughty. It
run
sounds dirty,
giving me a
but that's a different
ratio of
point.
liquid to powder, and after averaging things, I found that the ideal quantity was 1 milliliter of liquid to 0.293 grams of the catalyst. With this in
Do
mind,
some
I was
quick
also
maths.
able to calculate that I would need exactly 87 milliliters of the ethanol solution to perfectly coat
Ethanol
all of the
solution?
catalyst that was
Uh-oh.
still in the bowl,
Typo.
and I added that amount to the beaker. Then into this, I
Or maybe
added
it was
1.16
oh,
grams
okay.
of
It
sodium
is
carbonate, which would serve as my
which
source
is
of sodium ions,
very
and
funny
once it all
that
eventually
he needs ethanol to make ethanol in this, but don't really follow you since you're not a chemist, but that sounds cool. Yeah, don't worry about it. It's complicated. Like I said, it's a couple of elements. He's making some catalysts to try to turn water from the air and carbon dioxide from the air into ethanol. So that way you can drink and get drunk off of it.
dissolved, I went back over to the powder, and I quickly ground it to a dust.
And now you grind it to a dust.
I then
Took you
started
long
to
enough.
dropwise add the solution that I had just made, with a lot of stirring in between, and the goal now was to basically add everything and to coat the catalyst as evenly as possible. The key here, though, was that
What
in
the
doing
fuck?
so,
It's fuming?
all of the
That's
sodium
weird.
carbonate that I had added would get perfectly distributed throughout the powder.
Hmm.
I'd also
If it
specifically
fumed a little
used
bit, that's
1.16 grams of the
strange.
sodium carbonate
That kind of tells
because
me
I'd
it's not so
calculated
pure.
that
That
this was
should not be
exactly how much I would
reacting.
need to get a final catalyst that was 2% sodium by weight, which, according to the paper, was the ideal amount. But anyway, when I was eventually done, it was looking a bit
It
more
looks like
wet than I
crushed
would have
Oreos.
liked, except I felt that this was fine, and I quickly dried it by putting it in my vacuum oven. Then, when I took it out a few days later, what I had was a super nice and
Damn,
dark powder,
that is a
which in
void
theory
on
was
the
the
camera.
2% sodium ironat carbon catalyst that I was hoping for. And now, after working on it for nearly 4 months, I was finally done. At this
Oh,
point,
that's
I
what you
was
think.
also so beyond tired of this catalyst and this project in general that I ended up working on some other stuff for a week just to clear my mind.
Oh, that's not good.
After that, though, I felt that I
Whatever
was
that
ready to
is.
jump back into things and to make the second catalyst,
All
which
right.
at least initially seemed like it was going to be roughly 1,000 times easier. Because as far as I could tell, the whole process was
Let's see. Copper, zinc, aluminum catalyst was prepared by homogeneous precipitation method using urea as a precipitator. Typically an aqueous solution containing copper nitrate, zinc nitrate, aluminum nitrate, and urea. With that molar ratio, were added into deionized water, stirred hot for 2 hours, precipitate aged for 24 hours, filtered, um, washed by deionized water again, dried in an oven. Getting the powder, obtaining after calcination treatment, which is, yeah, basically just saying drying it at a high temperature for a while, but not too high of a temperature that it, oxidizes. Then let's see. Different amounts of alkali metal potassium were doped onto this catalyst by a wetness impregnation with potassium nitrate again. Okay. And characterizing by XRF, X-ray, uh, for fluorescence, yes, X-ray fluorescence. Okay, I mean, yeah, that does sound easy. It's literally just adding very common salts, stirring them together, and then drying your mixture. And urea, I guess, helps it all bind together, question mark, strange, and eliminates the nitrates? Guess the urea maybe, I mean, nitrate's really inactive in solution. I don't really know where that nitrate is going at that point. Hmm. Yeah, I guess I mean the urea is maybe making some hydroxides in solution. It is basic, gets added to the water, it rips off some protons from the water. The hydroxides could be attacking all the metals and they could be coming out as a solid in one kind of mixed lump together. That could serve as counter anions for the nitrates so they get left behind. I right. It's a bit of an odd
somewhat
idea,
similar,
but
except
it's
way more
straightforward enough.
straightforward. And the basic
Oh, Jinx,
idea
he
was to
owes me a Coke.
first make the so called CZA precursor, then roast it to make the proper CZA catalyst, and then after that, add some potassium ions to make the final 5% potassium CZA. The only slightly tricky part was that for some reason, the procedure in the paper was missing some fundamental key details like concentrations and amounts, which definitely wasn't ideal.
Oh, yeah.
However, after doing a lot of research and after reading every single similar procedure that I could find, I was eventually able to come up with my own numbers, and I was at least
I mean, okay, Niall, to be fair, it did literally say right here. It says copper, zinc, aluminum, 5 to 2 to 1 molar ratio. Yeah, I guess the concentration of the solution could matter quite a bit, but it's kind of like I'm reminded of like the joke from Scrubs about like, oh well, the Miss Sykes has a headache. How much how much Tylenol was she prescribed? And it's like it's regular strength Tylenol. You throw it at her and see how much enters her mouth, and that's the correct dosage. You're not gonna kill her. It's basically that. It's just like this is very mundane um metal salts. Just throw them together in this molar ratio, and as long as it's not a paste, it'll probably be fine when it crashes out and filters off. It'll be easy.
was missing some which after
Probably a
reading
high schooler
every
could do
single
this.
similar procedure that I could find, I was eventually able to come up with my own numbers, and I was at least pretty sure they would work. So, with these numbers in mind, I just went ahead and got started by first adding a bit over half a liter of distilled water to a large beaker, followed by 71.04 grams of
Now we're gonna get to
copper
see some pretty
nitrate.
colors because we're
This
dealing with
almost
transmission
immediately
metals
caused a lot of the water to turn a really
that
nice
aren't
blue
iron,
color,
and iron
and
turns
I
everything
quickly
brown.
followed this up with
Kind of a poop
35.1
brown.
grams of zinc nitrate, and 22.06 grams of aluminum nitrate. With all of these nitrate salts added, I then turned on the stirring to help dissolve everything, and when it all eventually disappeared, I dumped in the last ingredient, which was urea, and I added 180.18 grams.
Yeah, that'll make a pretty
Just
basic
like all of the
solution.
other stuff that I had added, this also dissolved relatively quickly, and when it was all eventually gone, I poured in some more water to bring it up to 2 liters. This then finally left me with a nice blue solution that contained a very specific concentration of urea and nitrate ions, and where the ratio of copper to zinc to aluminum was 5 to 2 to 1, and apparently, all of this was super important for how the final catalyst would turn out. I should say, though, that up until now, no reaction had happened yet, and to actually get things going, I was gonna have to heat it up. So that's what I did next by turning on the hot plate, and at the same time, I carefully watched it as the temperature slowly rose, and when it eventually got up to around 60°C, it didn't look like there was much of a difference. However, at least in theory, the urea should have been starting to break down into ammonia and CO2 gas,
Oh, yeah,
with
I
the
guess that
ammonia
is
causing the
why it's
solution
sensitive.
to
Okay.
slowly get more and more basic.
Probably gonna
Then,
get
as the
then
solution continued heating
metal
up,
ammonia
the rate of
complexes
urea
coming out from
breakdown
solution.
was supposed to increase as well, and at least based on the amount of bubbling that I saw, that definitely seemed to be happening. What I thought was much more interesting, though, was that when it eventually got to 95°C, the solution started becoming cloudy, and this was because it was at this point that the catalyst was starting to form. More specifically, the metal nitrates that I'd added were now starting to be affected by the pH, which was causing them to slowly turn into various hydroxides and hydroxycarbonates that were no longer soluble in the water. This in turn was causing them to slowly precipitate together as a very intimate mixture of copper, zinc, and aluminum, and with a very specific ratio of 5 to 2 to 1, and at least so far, everything seemed to be going exactly as planned.
Yeah, I
But
mean, this
anyway,
should be pretty
at
simple.
this point, I basically just had to
Yeah,
keep
it's
heating it like this for a
whatever
couple of
diagram I'm
hours,
drawing doesn't
which
matter.
should have been enough
It's not right.
time for pretty much all of the metals to get knocked out. During this time, the color also seemed to change quite a bit, which I assumed was good, and when it was eventually done, 2 hours later, I was pretty happy with how things were
Yeah, it
going.
does show you're making some kind
With
of
the main reaction now done, though, what I had
coordination
to do
complex.
next,
Something is
according to the
binding into that
paper,
copper. It
was
changes color.
age it for 24 hours, and in my experience, this usually meant to just leave it how it was.
Yeah. The precipitate was aged for 24 hours. Translation: I left it over like a day off that I took and then remembered that I didn't do this. Oopsie, but it worked.
However, at least based on what I'd seen in other similar procedures, that wasn't always the case, and what really didn't help was that there was absolutely no further information about any of this anywhere in the paper. So I kind of just ended up doing what I felt would work, and by that, I mean that I decided to leave it stirring, but to knock the temperature down to 65°C. I
Hmm.
then just let it sit there, and over the
That's
next
a
several
random
hours,
gut check
all I did
temperature.
was occasionally add water to it, and for the most part, it seemed like things were going okay, except for some reason, I just couldn't shake the feeling that I was doing something wrong. So, out of pure anxiety, I ended up reluctantly emailing the author again, which I really didn't want to do because I had already pestered him with way too many questions.
What's
However,
one
I'm
more?
glad that I did because it turned out that everything that I was doing was totally wrong, and he basically told me to do the complete opposite. More specifically, I was apparently supposed to keep it at the same temperature of around 95°C,
Yep.
and I was supposed to
Didn't say to change
completely
it.
stop the
Oh,
stirring,
well,
which he
that's
said
weird.
was important for catalyst particle size. So apparently, everything that I decided to do was wrong, and now everything that I had in this beaker was just a bunch of trash, and this was pretty disappointing.
Well, it's okay. It's only about,
But
unlike the other
that's
step,
just
this is like
kind of how it goes
$50 of
with
reagent,
chemistry
maybe.
sometimes. And what I did next was the
These are
only
all
thing that
dirt
I
cheap.
could
In
do,
fact, you could pretty much
which
find
was
these
just
in dirt.
restart by first getting rid of this entire reaction. Then after that, I basically redid everything that I'd just done, except this time, after heating it for the 2 hours, I transferred the entire thing to my sous
I
vide,
sous
which was
vide'd it.
normally meant to cook things like steaks.
Ah,
In this
God,
case,
they probably
though,
didn't
I
have
felt that
that
it was
in the
perfect for what
lab,
I
but
had to do, and it should have had
yeah, that
no
does actually
problem
make a lot
holding
of
the
sense for
reaction
this.
at a near perfect 95°C. On top of that, with the lid, it also should have been able to drop the water loss to almost zero, and this was amazing because it meant that I wouldn't have to constantly come back to add extra water. But with that being said, all I had to do now was basically wait, and when I came back to it 24 hours
Ooh, that
later,
is weird
it
layering on
at
it.
least seemed like
What's this? While it was aging, all the precipitate should have gone through a process of continuously redissolving and precipitating. This would ideally turn the somewhat disordered gel that it originally precipitated as into ordered crystals, with each metal mixed at the atomic level. Yes, that tracks. And, a basic diagram is like you have a. Oops, that's not the right tool. Hold on. Basic diagram. Just gonna draw a rough surface here. This is your like metal kind of surface. Just kind of imagine this is just like a big mixture of many atoms at the surface here. And they all have like some counter ions, which I'll just represent as like E plus or whatever. Don't worry about, or I guess it would be E minus in this case because they have ammonia. Actually, it has to be hydroxide. So then there's like also a bunch of like hydroxides here as well. So a bunch of hydroxides, bunch of metals, all kind of here at the surface with water, solid, and you have just little teeny bits of this dissolve into solution and little teeny bits that are just kind of dissolved in the solution coming back into the bulk solid. And this is just kind of a natural process of how anything that is at like an equilibrium with solution acts. Like, say, for example, you made a saturated salt solution at home. You just kept putting salt into water until the water stopped dissolving the salt. If you have that excess salt lying at the bottom of the glass, that salt is not just staying there doing nothing. At the atomic level, some bits of salt are dissolving into the water, but at the same rate, bits of salt that are in the water are resolidifying back onto other crystals of salt in the cup. So essentially you have the same thing going on here, and this allows a bulk kind of disordered solid down here to actually start forming a more crystalline material, because when coming back out of solution, the most stable thing for it to do is to form an ordered structure that is a crystal, rather than just kind of turning into this mess that is the bulk solid that was initially produced. Again, you could observe, theoretically, you could observe this with your, cup of salt water, but that's kind of happening at the microscopic level, so you can't actually look at it. But the fundamentally, when something stops dissolving in a solution in water, or any solvent, that just means that the rate of it dissolving matches the rate of it precipitating as solid again. It's not that it just completely stops, it is that there is just, math, and process one matches process two, or the process of dissolving matches the process of undissolving at the same speed. It's interesting. At least I think it is. Let's see here. So it does that into ordered crystals. The aging process is important because the metals don't all precipitate at the same time. Aluminum, copper will first, zinc last. So the material starts off unevenly mixed, redissolving and recrystallizing. This evens it out, so you get much closer to the ratio. Okay, yeah, I mean that makes sense. That's it. Man, this is a lot of work.
the aging process had made a difference. I mean, all of the solid stuff definitely looked different, and the solution was a darker blue color, and as far as I could tell, this was exactly what I was hoping for. At this point, I was also officially done aging it, so what I did next was quickly pull the beaker out of the sous vide. I then started pouring it all into a vacuum filter, and I was doing this to separate out all of the solid stuff and to get rid of the nice blue liquid, which was unfortunately just trash. When it was all eventually gone, though, all that I was left with was a little green
It
puck
looks a lot like the
that
thing from
should have been my
before,
crude catalyst precursor.
but eyes can be deceiving.
However, right now it was still a bit dirty, and I was gonna
Yes,
have to
looks
clean
can
it
be
up.
deceiving is the phrase,
So I
actually.
did that by washing it a few times with distilled water, and after that, I
Uh-oh.
transferred it to a vacuum chamber.
He stirred it.
Then, as it
He
sat
fucked up
there,
the
it
nanocrystalline
slowly
structure by
dried
stirring
up,
it.
and when I eventually took it
Maybe.
out a few days later, this was what I was left with, which was a beautiful chunk of nice and crunchy powder.
Ah, yes, the
At this
forbidden
point, I
mint
was
ice
also
cream.
officially done step 1, which I was really happy about, and so far, despite having to completely restart, this process was
I mean,
already
it's probably
way
not super
easier than
forbidden.
the other one.
It's probably not good
With
to
that
eat,
being
but this
said,
is probably
though,
not
what I had to
toxic.
do
It's pretty
next
mild
was move
elements
on
in
to
there, all
step
considered.
2, which, as I mentioned earlier,
Though it's probably
was the
caustic with all
roasting
that
step,
fucking hydroxide,
and I was a
so.
bit worried that it would end up being just as painful as the pyrolysis one. However, long story short, that was not at all the case, and it was probably the easiest thing that I had to do for this entire project.
Yeah.
Because unlike with the pyrolysis, I was able to do it with air present, and I didn't need any
So
specialized
the process of
stuff like a
calcination
tube
that's going
furnace
on here is
or
basically just
nitrogen
trying to
gas.
remove all of these
All I
hydrogens
had
that
to
are
do
still
was
in
load it into this little tabletop furnace
solid
and
and just kind of
slowly
leave a
heat
bunch
it
of
to
oxygens left.
350°C.
They don't want to do
And
this
during
too
this
high
time,
because then the
all
structure
of the powder
gets
would slowly
disturbed and
decompose.
kind of mess with the
More
structure. So you just want to
specifically,
do it
all of the
nice and
metal
gently, kind
hydroxides
of
and
right where it's
hydroxycarbonates
burning,
would slowly
essentially.
break down, releasing water and CO2 gas, and leaving behind a mixture of copper oxide, zinc oxide, and aluminum oxide, which was my proper CZA catalyst. This also caused the powder to turn completely black, which was exactly what I wanted, and after leaving it overnight to cool down, this was what I was left with. Nearly 36 grams of hopefully decent CZA catalyst that at least looked like it had been roasted nice and evenly, and overall,
Once
I was
again,
very
most of that
happy
color
with how
comes
it
from
had
the
turned
carbon
out.
or the copper,
At
just
this
like
point,
the
though,
blue color
there was
used
of
to.
course one last thing that I still had to do, which was to convert it to the
Magic of being a
5%
transition metal.
potassium CZA, and again, this was thankfully super easy and straightforward. This was mostly because after learning from the last one, I already knew exactly how to do it, and I started by testing how much water the powder could absorb. Then after that, I quickly put together the coating solution, except this time I just used pure water and not a solution of water and ethanol, and I used potassium nitrate instead of sodium carbonate. I also used 4.48 grams of the potassium nitrate so that the loading would be exactly 5%, and once I had added all of the solution
I'm
to the
interested to see if
catalyst,
like these
I
catalysts are going to be
dried it
like
in my vacuum oven.
physically stacked on top of each
Then, a
other in
few
his
days
reactor,
later,
or if
I
they're just
took
going
it
to be
out,
mixed together,
and
or
what I
like
had
what the
now
story
was
is with
about
that.
35 grams of super nice and dry powder that should have been my final 5% potassium CZA,
Uh,
and at this point, I was feeling pretty good about how everything was going. At the same time, I also couldn't believe just how much easier and faster this one had been, especially considering that from start to finish, including the screw up, it had barely been a week. But moving on,
Yeah,
with
and that's
both
what
of the
happens when you work with
catalysts
just
now
basically
finally
mixing
done, the only thing
metal
left to
salts
do was to
together
mix them
and just
together
doing acid-base
and to
chemistry.
load them into
Lot
the
simpler.
reactor. So that was immediately what I
All right,
started
so
working on next.
break down this
and the
reactor for
first
us,
thing that I
Nile.
did
What the
was
fuck did you
use some
make?
sieves and a hydraulic press to get them to a very specific and uniform grain size of 20 to 40 mesh. Then after that, I quickly added 25 grams of the CZA, followed by all of the iron catalyst that I had made, to a glass jar. At the bottom, there was also already a small amount of inert quartz sand that I'd added beforehand, and this was because according to the paper, including some sand was supposed to make the final catalyst slightly more efficient. But with that being said, once
Sure, why the
everything
hell
was
not?
loaded in, I shook it around to mix it up
I
as
sure
much
wouldn't
as
know why.
possible, and when I eventually felt that it was
Silica
looking
just
good,
helps space it
I
out, I
went over
guess?
to the main
Maybe the
setup
silicon does
and I got
something.
the reactor.
Probably not,
Then, after bringing it over to
if
my
it works
vise
without it,
and
but...
clamping it in
Hmm.
upside down, what I did next was carefully add all of my newly mixed catalyst. I also tapped it a bunch of times with a hammer to help pack it down as much as possible, and after topping it off with a bit more quartz sand, I added some special goo to the threads along with a puff of quartz wool, and I sealed it with an end cap. At this point, the reactor was effectively ready, so I quickly tested it by passing some high pressure CO2 through it, and once I saw that it looked good,
Okay.
I blasted it with a heat gun to cure the sealant.
Hmm. Okay, alright,
Then
so
after
then
that,
the
I
two
reattached it to the
catalysts
main
are just
setup
mixed
by
together.
reconnecting the compression fittings
So my
and by
question was
clamping the
answered.
reactor to the stand. While I was at it, I also rewrapped it with the custom heating jacket that I had ordered from Alibaba, which would allow me to precisely heat the tube all the way up to 600C.
Ordering it from Alibaba,
And with
that's how
all
you
of this
know
in
it's going to
place,
work.
I was feeling pretty excited. This was because after nearly
Channeling
2
the magic
years
of
tedious
discount
work,
chemistry.
the full setup with the catalyst was finally done, and at least in theory, I was now very close to achieving my dream of air alcohol. At the same time, though, I was feeling a bit nervous because I still had no idea if any of this would actually work, and it was very possible that it would all just end up being a bunch of useless junk. Or worse, it could end up catastrophically exploding or something,
Well, let's
but
not think of that
I figured
issue.
there was only going to be one way to find
You know,
out,
sometimes denial is
and
the
I was going to
best
have to actually try
safety
running it.
tactic.
So that's what I immediately started working on next, where the first step was to load up the system with all of the air water and air CO2 that I'd collected years ago. And at least for the water, this was going to be extremely simple, and I basically just had to pour it all into my hydrogen generator.
Alright, well, we're
For
already
the
at step 1,
CO2,
so
though,
that
it
went
was
without a
going to
stress,
be a
or
bit more complicated
without any stress.
because it was all still trapped in this crunchy sodium carbonate, and to use it, I was first going to have to release it, and then I was going to have to somehow recapture it, and then I was going to have to store it as a pure high pressure gas. However, I felt that I had a relatively simple way of doing this,
Yeah.
and I just
I'm
went
pretty sure
ahead and
you
got
filled
started
up
with
gas
it
tanks before,
by
Nile.
transferring about half of it to a huge round bottom
Delicious smoke.
flask, followed by a whole bunch of distilled water. Then after that, I quickly put together this somewhat complicated looking setup with this huge funnel over here that was filled with a bunch of acid, and when I opened the valve, it all started flowing into the flask. This then immediately caused there to be a bunch of bubbling, and this was because it was reacting with the sodium carbonate solution and releasing some of the CO2 that I had trapped years ago. As it was
Years
made,
ago.
all of the
God.
CO2 was also leaving the
Yes,
flask,
this
and it
is
was
a
getting dried
several
as it
year long
passed through the
project.
condenser and through the calcium chloride.
I don't know if I would trust the
The key
damn
here, though, was
carbonate
that
at that
pure
point. Could
and
get
dry
some random
CO2 was
shit from
then
the air in there.
eventually making it to this chamber here,
But
and
you're
after
distilling
running
it,
the
so...
system for a few minutes, I added a whole bunch of my own homemade liquid nitrogen.
Oh, just to flex on us. I guess that technically also comes from the
This caused
atmosphere
the
too, so you
chamber
can
to
chalk
quickly
that up
cool
to a
down
air to
the
alcohol.
point that it could start freezing the CO2 gas on the walls of it, and the idea here was to trap it in its pure solid form, which is commonly referred to as dry ice. At this point, I also didn't have to do very much besides occasionally adding more acid to the funnel and more liquid nitrogen to the bowl, and patiently waiting for all of the sodium carbonate to disappear. So in the meantime, I went and got my pressure chamber from the main setup that was originally built for my aerogel project years ago, and I clamped it upside down in my vise. While I was at it, I also added a funnel and a camera, as well as an argon line, and after that, I just went back to waiting for it all to react. It was then a few hours later when all of the sodium carbonate
Oh, there we
was
go.
finally gone, and what I did next was pull the chamber out of the liquid nitrogen. I then opened it up, and I quickly started breaking apart all of the dry ice, which was honestly a surprising amount, and when it eventually looked like it was just a bunch of snow, I felt that it was good to go. So I went over to the pressure chamber, and after flushing it with a bunch of argon, I started loading it in as fast as I could because I wanted to lose as little dry ice as possible. Then, about 30 seconds later, when
See
it
it
was
melting
all
so
in the
quickly because the
chamber,
metal's so
I
conductive
quickly
into that
sealed
dry
it
ice.
by adding a small plug, and after that, I immediately looked over at the pressure gauge,
It's upside
which was
down.
now starting to
How are you gonna look
rise.
at it?
And when it eventually got above 100 psi, all of the dry ice suddenly started to melt because at this pressure and at room temperature, it instead wanted to exist as a liquid, and I thought it was really satisfying to see it all slowly liquefy.
Ah, liquid
With
CO2.
all of that done,
Still fun to
though,
look
I
at.
now had a chamber that was filled with about 250 grams of CO2, which should have been more than enough, and I reattached the whole thing back to the main setup.
I feel like CO2 would be such
With
a
it
useful
securely in
solvent if you
place,
could
the
actually
full
use it like
system
at
was
room
then
temperature and
fully ready
pressure.
to go, and at least
I mean, it already is useful
theoretically,
under like,
there
high
was
pressure
very little
stuff, but it's like
stopping
so
me
hard to
from
actually get
just
a hold of,
going ahead and
you know,
running it.
as your
I
average
mean,
chemist.
besides the fact that it was already 3 a.m. and I was absolutely exhausted
I
because
have a
this
harebrained
entire
idea involving
CO2
using
part
CO2
had
as a
taken
cooking
way
tool,
longer
but
than I had ever
I'll
expected.
save that for another stream.
When I came back to it the next morning, though, I pretty much immediately got started by first opening up the CO2 chamber and by adjusting the pressure regulator. And as I did this, CO2 started flowing out the back of it. It was then getting pushed up the copper tube and through this much bigger tube, which was removing any potential contaminants like moisture, oxygen, and hydrocarbons. And once it got to the end of it, it was supposed to be extremely pure. But with that being said, with the
All right,
CO2 now up
CO2
to this part
feedstock
here,
required.
I quickly opened this needle valve as well as this bleed valve, and I let the CO2 flow through this part of the system until I was sure that I had pushed out all of the air. Then after that, I moved on to flushing the air out of the rest of the system, which was relatively easy, and all I had to do was use these four valves here
I mean, how
and
much
to
is having the
alternate
air
them
in your
back and
system
forth.
actually going to cause
This
problems?
was
If anything,
because
it's just
each
going to
of
cause a
them
little
was
bit of
equipped with
like
a
a dead
vacuum
space.
line as well as an argon line, and by repeatedly going between vacuum and argon on each section, I was able to completely flush out the air and replace it with a slight pressure of inert argon.
Yeah, sure.
With
Just
the
to be
system
safe. It
fully
makes
air
sense.
free, I was then able to safely flip on my hydrogen generator, which almost immediately started electrolyzing the air water and splitting it into hydrogen and oxygen. However, all of the oxygen was just being thrown away, and only the hydrogen was being kept. And when the pressure of the hydrogen eventually got up to
As a lab safety guy, oxygen is not the worst thing to have being put out into the atmosphere. It is, after all, the thing we breathe. Um, but counterpoint, to have oxygen just being produced and strewn about into the atmosphere and, you know, maybe kind of sort of mingling with some of the flammable things in the lab space. Perhaps what if there's a gas leak down the line with the hydrogen? I feel like that maybe should have been vented somewhere, but it's okay. He didn't blow up. Evidently he uploaded the video, so
1 megapascal or 145 psi, I opened this special valve on the reactor side of the setup. This allowed pure hydrogen gas to start traveling down a tiny tube hidden in the back and through the reactor, and I adjusted the flow rate by opening this valve here and by carefully turning a knob
it's like watching
on
a
the hydrogen
maestro orchestrate
generator.
his
Then, when I
orchestra,
eventually got the reading
just
on the
turning all the
generator to
knobs and
300
dials
mils a
and
minute,
putting the
which was
arms
the
in the right
max amount of
place. It's
hydrogen that the
impressive.
machine could safely make, I turned on the heating jacket. I also started cranking up the temperature, and this was because what I had to do now was activate the catalyst and to turn it into a form that would be able to make ethanol. So that was exactly what I did, and when the temperature eventually got to around 330 C, I noticed that some small drops of water were starting to fall into the flask. Then, by the time that it made it to 400C, I saw that a little puddle had formed, which I thought was good, and I felt that this was strong evidence that the catalyst was actually getting activated.
Yeah, I
This
mean,
was
where else
because
would liquid
water was a
come from?
direct product of the activation, and it was forming as the hydrogen reacted with the catalyst. More specifically, it was reacting with the oxygen in the catalyst, and in the case of the potassium CZA, it was supposed to be attacking the copper oxide and reducing it to copper metal.
A point of order. How much of this is a catalyst at that point? Well, I guess maybe if the carbon dioxide is coming in and regenerating the oxygen. Otherwise, this would just literally be a reagent rather than oxygen or a catalyst. A catalyst, by definition, needs to regenerate and not be consumed as part of a process. It can be partially destroyed during the process, but it must be able to like complete a cycle and come back onto itself and reform. So by the end, you don't lose any of it. Um, so I'm guessing the carbon dioxide contributed its oxygen to this in the form of regenerating the catalyst.
This metal was then supposed to just sit there, all bundled up with the zinc oxide and aluminum oxide, which weren't going to be affected by the hydrogen. In the case of the sodium iron at carbon, though, the hydrogen should have been reacting with all of the iron oxide and reducing it towards metallic iron. And I say towards because this iron metal would never really exist, and it was supposed to be almost instantly picked up by the carbon that was surrounding it and turning into iron carbide. Both of these together would then make the so called activated form of the catalyst, and
Hmm.
at least in theory, they were
Hey,
supposed to be
reverse
able
water
to
gas
work
shift. I was talking
together
about that earlier.
to make ethanol. But anyway, after cooking it for
Yeah, I
2 hours,
heard about
it
that,
should have
Chris.
been
I
fully
don't have
activated,
much to talk
and
about
what
in
I
the way
did
of the
next
celebrities
was
right now,
close the
unfortunately.
hydrogen
I don't
valve,
really
and I
have much
replaced it
about
with a
them to
very
say.
slow flow of argon. Then, right
Differential
after
black hole
that,
over here,
I
after all.
started lowering the temperature of the heating jacket, and my goal was to eventually get the reactor down to 320C, which was the optimal temperature for the ethanol reaction. However, I knew that this was going to take a bit of time, so while I was waiting, I decided to go over to the other end of the setup and to start preparing the hydrogen and CO2 gas mixture. This was also, thankfully, going to be relatively easy, and the first thing that I did was just open this valve here, which caused hydrogen to rush in and to spike the pressure in this section to 145 psi. I then used the regulator to knock it down to the same pressure as the CO2, and with the bleed valve open, I used this needle valve to increase the flow of hydrogen, and again, I adjusted it until I got
I
300
got
mils a
lost somewhere in
minute.
the middle of this. I just know
At the
now that
same
he's
time,
introducing
I
the
also
gases
looked at the
together.
ball in the
I
flow
think.
meter to make sure that it was indicating the same flow rate, and when I confirmed that it was, I opened up the CO2 valve. This caused the CO2 to rush in
Oh, there
and
we
to
go.
mix with the hydrogen gas, and what I did next was try to adjust the flow of CO2 until the ball got to just above the 45 marking. Because at that point, the flow of the CO2 would be about 100 mils a minute, which would be one third that of hydrogen, and according to the paper, that was the ideal ratio. But either way, when it eventually
Yeah, I mean,
got
it makes
there,
sense. You need to
my
add
low
6
pressure
things of
gas
hydrogen
mixture
to the
should have been good to go,
carbon to make
so I
ethanol.
closed
So,
the bleed valve and I opened the
or
valve below
yeah,
it.
the ratio would be 3 because there's
This
2
then allowed it to
carbons and
flow into the
6
next
hydrogens
part
in the
here
ethanol.
that
So,
was filled
yeah,
with
that
some
makes sense
silica beads.
stoichiometrically.
Except in hindsight, I honestly think it was kind of pointless. And what was much more important was that it eventually made it to this section here and that it started filling the small gas cylinder. This was because now I was actually starting to collect my gas mixture and I was making a very important little buffer that
Hmm.
the gas booster could pull from. And when it eventually got to around 80 psi, I opened this valve. This then allowed the gas to rush into the booster, and at first, nothing
Oh,
happened
what's a gas
until
booster?
I started turning
Tell
the
me,
valve
Nile.
on the left, which caused the whole thing to come to life. And by that, I mean that it immediately started compressing my gas mixture,
Hmm.
and with every cycle of the system, the pressure of it slowly increased. I should also say that this entire thing didn't need any electricity to do this,
This is
and it was
terrifying.
working entirely on compressed air that was being fed in through the blue tube. But with that being said, when I eventually saw that it had been boosted all the way up to 800 psi, I opened this valve here to release this new high pressure gas mixture into the next part. Then, after waiting a couple minutes for the pressure in the system to stabilize, I immediately started adjusting this regulator. I also did my best to set it so that the gas coming out would get knocked down to about 725 psi.
This is so
And once I had
complicated.
done that,
It's
I was
literally mixing
feeling
2
pretty
gases
excited
together
because now
into another
my high
tube
pressure
or
mixture
into
of
another
hydrogen
cylinder,
and CO2
and
was
then upping its
officially ready
pressure.
to go.
So that way you can get it to a
So
lower
what I did
pressure.
next
So that
was
way you
check
can
out the
then feed it
temperature
through
of
these
my
complicated
reactor,
catalysts.
and when I saw that it
Hopefully
was
get ethanol out
already
of it.
sitting nicely at
It's
around
ridiculous.
320 C, all of my
But I guess
excitement
the concept is
almost
ridiculous,
immediately
so
shifted to nervousness. This was because at this point, everything was good to go, and finally, after way too much effort, it was time to see if it would all actually work to make ethanol, and apparently all I had to do was open this valve.
Okay.
moment of truth.
Good luck me, I guess.
So that was exactly what I did, and this almost immediately caused the high pressure gas to rush into this last section and into the reactor, and when I looked at the pressure gauge, I was happy to see that it was increasing. I was also very happy to see that so far nothing had exploded, and that there weren't any jets of fire shooting out, and with it seemingly safe, I carefully adjusted the flow rate a bit using this valve here. Then after that, I felt that for the most part, everything was looking pretty good, and now, at least in
Just
theory,
walk
as the
away.
hydrogen and
Don't let the
CO2
explosion
passed
hit
over the
you.
hot catalyst, it should have been turning into some amazing ethanol. How this was hopefully happening was also apparently quite complicated, and the paper actually suggested 4
Oh my god. Yeah, that's holy shit, that's so much to break down. Yeah, to be fair, hydrogen and carbon dioxide do have a lot of complex and like kind of just funny wobbly reactions and like different oxidation states that they can be at on a metal surface. They interact with those metals way more than you think they would, at least with a kind of standard amount of chemistry knowledge, but yeah, you're probably forming formates and other organic kind of subspecies, maybe some like weird carbon hydrogen carbene kind of thing sticking out of there, and you're reducing down to aldehydes. Once you introduce oxygen, then you might have ketones, you might have carboxylic acids. You basically get kind of the whole just stew of organic chemistry with carbon, oxygen, hydrogen happening, and hopefully by the end of it, you end up getting the ethanol you want.
different pathways that were probably occurring all at the same time. However, the main idea behind all of them was kind of similar, and they all started with hydrogen and CO2 getting picked up by the potassium CZA. And while they were there, on the surface of the catalyst, they would react together, which would turn the relatively inert CO2 into something that was much more reactive, like carbon monoxide or formate. These intermediates would then be able to diffuse away, but they wouldn't make it far, and they would almost immediately come into contact with the iron based
Then the iron
catalyst.
picks it up
This would then use
because
some
the
more
iron's a really good
hydrogen
pi
to turn the
acceptor,
carbon
pi donor.
monoxide into a small hydrocarbon fragment, and after that, it would link this fragment to one of the reactive intermediates that was just made by the potassium CZA. This would lead to the formation of a new aldehyde intermediate, which would then quickly react with even more hydrogen to produce the final ethanol. And all of this was, of course, happening at 320 C,
And reported
so any
efficiency of
ethanol
about
that was
like
made would be in its gas
13%.
form,
Ugh.
which would then get pushed out of the reactor and into the cold condenser, where it would hopefully liquefy before dripping into the flask. Also, one thing that I should mention is that this reaction isn't super efficient, and only about 35%
Oh,
of the CO2
35%.
that reacts is supposed to turn into ethanol, and a lot of it would be turning into other hydrocarbon side products. On top of that, a lot of unreacted hydrogen, CO2, and carbon monoxide would for sure be coming out the end of the system,
Delicious.
which was why it was
Flammable.
very important to feed everything
Dangerous.
through this tube in the back and into my fume hood.
Okay. Good thing
But
he
with all
did at
that
least to
said,
that, so he
by
doesn't end up
now,
poisoning
the
himself.
system had been running for at least several minutes.
Although, can you
and at
imagine
this
carbon
point,
monoxide-induced
I was starting
NileRed?
to
He'd come
feel
up with some
pretty good about
crazy
how things
ideas,
were
I'm
going.
sure.
I mean, that wasn't until I
I'm
realized
converting
that the
the
reactor
demons
was
in my
failing
head
to
into
achieve
Laffy
the
Taffy.
proper pressure of 725 psi, and that I wasn't going to be able to do anything about this. This was because there was apparently something wrong with the needle valve that was making it impossible to reduce the gas flow any more than what it was, and this meant that it was going to have to stay at around 600 psi, which wasn't exactly ideal for this reaction.
Unfortunate.
However, as far as
Because
I
you'd have to
knew,
spend
it
months
still
making other
should have been able
catalysts
to
again.
make ethanol,
I mean,
and
not,
it would just be a little less efficient, and I figured that my only real option was to just keep going with it and to hope for the best.
Gotta give it a chance.
So that's what I did, and at some point, I decided to freeze the receiving flask with a bunch of liquid nitrogen just to be absolutely sure that I
just to get
captured
real desperate
everything
about
that
it.
came over. This also caused the entire flask to slowly turn white, which confirmed that I was for sure collecting something, and I was really hoping that this was
Well, the
mostly my
carbon
amazing
dioxide's
ethanol.
also coming out from
But
that. You might be
anyway,
collecting
as
just
it
dry
sat
ice in
there, I
there,
slowly
Nile.
got more and more excited as I saw it gradually build up, and after patiently waiting about an hour, I had collected what looked like a decent amount. So I just decided to shut it down,
Yeah, I think he
especially because it was already 4
forgot
a.m. and I was
about the
absolutely
fact that he
exhausted.
did this
And
exact
I
thing
did this
before
by
to
closing the
harvest dry
main gas
ice.
valve and by switching it over
I'm
to a flow of
guessing this
argon.
run is maybe not
Then
that
after that, I
successful.
took away the liquid nitrogen and I started warming it up with a heat gun. And as
I
I
mean,
was
it'll get
doing
rid of
this,
stuff, but
I was just
still,
hoping that it
there's
would
not going
all
to be much
magically
left.
melt and form a huge pool of ethanol. However, almost immediately, I started getting really concerned when I saw that a lot of it was just vanishing, which meant that unfortunately, most of it was probably just unreacted CO2.
Yep.
Then, as I kept heating it, my concern only got worse and worse as it continued disappearing. And what was really sad was that by the time pretty much all of it had melted, there was basically nothing left.
It's just that water
I
that you
mean,
started off
there was
with
definitely a small puddle there, but it
and that you
looked like it
never
was at
drained.
most maybe a few milliliters, and I was pretty sure that this was all just the water that was left over from the catalyst activation. This was also very bad, to say the least, because this basically meant that the catalyst had not worked properly, or more likely, even at all, and at this point, I was not exactly having good and positive thoughts
And
about
would
things.
be thrilled about
Yeah,
remaking
so that's
all that catalyst,
that's
especially the
it.
iron.
Total failure. I have officially given up all hope, and I believe the catalyst is crap. So
But once you give up all hope,
yeah,
that's usually when you
give up.
come back. It's a cycle of it's so over and we're so back.
But that all quickly changed when I came back to it only several minutes later, and I noticed that there was somehow way more liquid, and that there were drops continually coming over, and I had no
That's
idea
weird.
why this was happening.
That makes no sense. There's now a steady drip rate under argon. I'm struggling to understand what's happening. What?
That is
What
weird.
is that that's coming over?
Maybe just that it's cooler
At the
now,
same
like, and the
time, I
catalyst is
also
working
started
better,
thinking
even though
that
that's
some of
not
this
what the paper
could
said.
be my ethanol, and that somehow it had just gotten trapped in the reactor or something, and I actually started to get some hope that it wasn't just a complete failure.
Time to taste it.
So, what I did next was quickly take the flask off the setup, and after swirling it around to mix it all up, I transferred a small amount of it to a glass tube.
Oh, okay, it's not
I then
tasting it yet.
carefully loaded this tube into my little NMR, and after patiently waiting a couple of minutes, this was what it eventually showed me. And at first, I was kind of sad because right away I saw this massive peak here, which told me that it was basically just water. However, when I looked a bit closer, I noticed that there were some small peaks down here,
Yes, there's
and after
crud.
stretching it out a
We
lot
love
and
crud.
labeling them, I was actually pretty happy with what I saw.
That is actually pretty exciting. Wow.
Because what I saw was that without
Well,
a
that makes
doubt,
sense. There's a
there
triplet,
was
there's a
some
quartet, and
ethanol in
there's a
there,
singlet there.
which meant that the catalyst had in fact
Which,
worked to some degree.
if we weren't already at the 2-hour mark, I would explain how we get the shapes that we do in NMR, but suffice to say, we don't have that kind of time. We'll just leave it at the fact that because there are 2 of the hydrogens that are labeled to be here, they are interacting via the weak nuclear force, I believe, with the 3 protons here on this carbon. So the B ends up splitting into 4 distinct peaks, because it's the number that of atoms it's interacting with plus 1, and then these A interact with the 2B, so 2 plus 1 is 3, splits into 3 peaks. It's basically a representation of the different possible energy configurations of all of the states of the nuclei of these hydrogen atoms. It's pretty damn cool.
It worked?
This also meant that at least technically,
He's
I
taking these
had
measurements at like
succeeded
5
at
a.m.
turning air into alcohol.
Poor guy.
And at this moment, I was feeling pretty excited.
It made a detectable amount of ethanol.
Barely.
It's working.
But that's something.
Maybe. It's maybe working.
At the same time, though, it was hard to feel too excited or celebrate it because what I had made was still nearly pure water with an almost undetectable amount of alcohol in it. And what also really didn't help was that, unfortunately, I wasn't even sure what had gone wrong. But after thinking about it for a while, and after doing a bunch of research, I was eventually pretty sure that the main issue was that I just completely failed to properly activate the catalyst. On top of that, I had only run it at 600 psi instead of the ideal 725, which just made everything even worse by making a barely functional catalyst even less efficient. On the bright side, though, the fix for all of this seemed relatively simple, and for the most part, I figured that all I had to do was replace my little hydrogen generator with one that could output a lot more hydrogen.
Time to spend more
That
money.
was exactly what I ended up doing, and while I was at it, I decided to do a few
Christ,
more
there's
fixes
no
and
space at that
upgrades,
table.
like swapping out the valve at the end for one that would actually seal, and changing out the flow meter and the bubbler for ones that could handle much more gas. I also spent a few days collecting a lot more water, which would be needed for this huge hydrogen generator, and this time it was
Gotta
way
love the
easier
academic
because
honesty. Still
it
bothering to
wasn't
collect
winter,
water from the
and there
atmosphere.
was plenty of humidity in the air. But either way, with all of that done, the new setup was basically ready to go, and I was feeling pretty hopeful that this time it would actually work. So I basically just cleared my schedule and I jumped right into it by first generating some more CO2 with the last bit of sodium carbonate that I had, and by transferring it all to my aerogel chamber. I then reconnected it back to the system, and after flushing the air out of the entire thing, I turned on my brand new hydrogen generator. Then after that, the first thing that I did was reactivate the catalyst, which as I mentioned before, likely didn't get fully activated the first time, and I felt this was mostly because of the really low flow of hydrogen. What also made this problem even worse was that for some reason, I had only run the activation for 2 hours when it should have been done for closer to 8, and overall,
Well,
I think
sometimes
I
you
just
just misread a
completely
paper.
screwed up. But with all that being
To
said,
be fair to him,
I
it was
then
like
waited
3
for the
a.m. when he was
catalyst
running
to
this, so
hopefully activate,
fucking Freddy
and over
Fazbear
the
is
next
about to
several
like maul
hours,
his
I
ass.
ended up collecting way more water than I did before, which I felt was a really good sign. And when it eventually got to the 8-hour mark, the catalyst should have been good to go, so I dropped the temperature to 320 C, and I quickly prepared the gas mixture. Then, when I felt that I was ready, I unleashed it, And I was very happy to see that with my new valve and with the significantly bigger hydrogen generator, I was easily able to keep
Yeah,
the pressure at
725.
around
750.
725 psi. I was also very happy to see that this time there was a lot more gas passing through the bubbler, because this meant that
Oh
more
boy,
gas
5
was
a.m.
passing over the catalyst,
Time to make
which in
ethanol.
turn
Time to make
meant that I
moonshine.
could be making ethanol more quickly. At the same time, though, I still had no idea if it was
I think
actually
it would be a
working,
compelling
and
SpongeBob
even
episode
after
if
letting it run
Patrick was
for
trying
an
to run an
entire
illegal drug
hour,
business
I
outside
had
of
no idea if I'd even produced
his rock
anything at all.
thoughts.
So I decided that I had to check on it by getting rid of the liquid nitrogen and by letting all of the frozen stuff melt, and at first, it was looking really promising. However, as it slowly
Once again,
disappeared, it eventually became clear that things were in fact not looking promising, and once it had all melted, I was honestly kind of devastated. This was because all that was left was barely a milliliter of liquid, and apparently, even with all of the extra hydrogen and with the more activated catalyst, it was somehow even worse than my first attempt. But despite that, for some reason, I still had faith that the catalyst would eventually work. I also really just felt
translation.
that it needed some more.
Translation. He had faith that the catalyst would work because losing faith in the catalyst would mean that he would have to fucking make it all over again, and it would take him like 3 more months. I've been in that situation before. Boy, can I relate. Maybe not in the sense of catalyst in 3 more months, but in the sense of, damn, my starting material sucks, but I don't want to admit that it sucks because then I would have to spend another 2 weeks making more of it again. Ugh.
Time to get going, so I decided to put the liquid nitrogen back and to let it run for another hour. Then, when I started thawing it out again, I was really hoping to see that some sort of miracle had happened and that the catalyst had just magically worked this time.
Miracle.
And well,
No.
that was kind of exactly what I saw.
What?
More specifically,
That never
unlike
happens.
before, there was a whole bunch of stuff in the middle
Doesn't happen to
that
me, at
didn't
least.
just look like it was dry ice, and most importantly, as I kept warming it up, it didn't seem like it was just vanishing. In fact, it was eventually clear that it was starting to melt, which told me that for sure, it wasn't just dry ice. What was also really exciting was that, unlike last time, it kind of looked oily, or at least it didn't look like it was pure water.
Cloudy.
And
Got
when it all
some
eventually
crud
melted,
in it.
I
That's the
actually had a
55%
surprising
other
amount.
hydrocarbons as reported in the
Then, when I
paper.
started pulling it all out with a pipette, I genuinely couldn't believe just how much liquid there was,
Ugh.
especially considering that the previous
That looks
hour
nasty.
had basically produced nothing.
I would
On
not
top
be
of
drinking
that,
that.
what I thought was really interesting was that when I smelled it, it was very different than all of the other times, and it was not at all what I was expecting.
Huh. Smells like banana or something. Smells fruity.
Well, I mean, you are
But either
making
way,
a
after
weird
this little
combination
bit
of
of surprise
alkenes and
success,
carboxylic
I
acids
decided
and
that
things
I
like
might
that.
as well
Banana
just
oil
keep
is
running
kind of
the
in that
system
family, so.
and to use up the last bit of CO2 that I had. So that was exactly what I did, except this time I decided to push the system to the limit of what it could handle.
Oh boy,
by
that's under
increasing the gas
high
flow over the
pressure.
catalyst to the absolute max. This was mostly because it was getting late and I wanted to go as fast as possible, and for the most part,
And said, fuck it, I
this
might blow
should have been
myself up. It's
fine.
okay.
I mean, I did know that this was going to put a lot of strain on my air compressor, which was not really rated to run the gas booster constantly,
It's gonna explode.
and I wasn't too surprised when that was exactly what
Oof.
happened. But at the same time, I also didn't really care that it happened, because just by chance, I had basically used up all of the CO2 that was left, and at this point,
Yeah, I
felt
would
it was
not
a
be
good time
fucking
to
around with a
end
pressure
things.
explosion.
That I think.
That is a
I think that.
bad scene if that goes
So,
bad.
just like every other run, I
But
then
glad it was
got
just
rid
a
of the
hose
liquid
that popped
nitrogen,
instead of
and as it
anything
slowly warmed
steel.
up, I was
That would be a
assuming
frag
that
grenade.
at best, I would get something similar to the last run. However, that apparently wasn't the case, and somehow it looked like there was even more, and after heating it for a few minutes, I was honestly shocked by how much there seemed to be.
Ugh, that looks like the fucking ice that melts after in like the city. You know, when the city piles everything onto the sidewalks over the weekend, and then it just melts over like the course of, you know, the entire winter, and you just see everybody's like scum and trash and like, dog shit just kind of combined into one. That looks hideous. Ugh, I can't believe he's gonna extract ethanol out of that and drink it.
Then, once it all eventually melted, I quickly pulled it out and I transferred it to another vial. And again, I was kind of shocked when I was almost able to fill the entire thing.
This is like double or triple what I got from the last one. How? How is it so much more than the other one?
I don't know, higher
So
pressure must have been better
apparently,
for it.
properly reactivating the
I
catalyst
mean, this
did
needs
in
high
fact
pressure
do
to like
something,
squeeze
and
the
there seemed to
gases
be
together.
some sort of trend going on where every time I ran it, it seemed to work better.
Hmm.
What was that? Was that tiny text
Interesting.
there? I want to read that.
Either
Oops.
way, though,
Hmm.
I ran it, it seemed to work
The peaks in the final run were smaller, indicating that the ethanol was likely more dilute. However, the ethanol peaks were higher than the methanol, indicating it was likely making proportionally more ethanol. Okay, I mean, yeah, that's an improvement.
better. Either way, though, at this point, with literally no CO2 left, I was officially done using my whole setup, and what I had to do next was purify all of the air alcohol that I had made. This was especially because what I had now was still full of nasty side products and things like methanol, which I would definitely have to get rid of before I could even think about tasting it.
My poison has too much
So that's what
poison
I
in it. I need
quickly
to remove
did
some of the
next
poison so
by
that way I
first
can
getting a
drink the good
secretory
poison,
funnel
not the bad
and by
poison.
dumping in everything that I had. Then after that, I drained out the lower water layer, which should have contained pretty much all of my ethanol, and I left behind all of the banana smelling oily stuff that was floating on top. I should also say that I didn't know exactly what this stuff was, but it was probably just a mixture of random hydrocarbons and other side product crap. But anyway, after just that, what I had was already a bit cleaner, except it was still really dirty, and I was of course gonna have to do a lot better. So, what I did next was quickly put together the smallest distillation setup that I
Good poison
could
is an addiction.
because
Yeah,
I wanted to
that's
lose as
ethanol.
little ethanol as
That's alcohol for
possible.
you.
And when I felt that I was ready, I turned on the stirring
Cause
and
of and
heated.
solution to all of
I
life's
then
problems.
patiently waited for the temperature to rise, and I ended up tossing out everything that came over before ADC, which should have been mostly methanol and other junk. Once it got a bit over ADC, though, ethanol should have been starting to
Nice
come over,
distillation.
so I quickly swapped
Separating
out the vial
materials by
for a
boiling
fresh one.
point.
I then continued collecting it, and during this time, the temperature
Ethanol
slowly
boils
rose
around 80
as more and
Celsius.
more water came over with the ethanol,
Water boils are
and when
towards
it
100,
eventually
but
got all the way up to 95
they kind of have
C,
a
I pulled
co
away the vial.
distilling
Then
temperature
after
called
that,
an
I added a
azeotrope.
stir bar to it, as well as some activated charcoal to clean it up as much as possible, and after leaving it like this for about an hour, I filtered it through some cotton. This allowed me to get rid of all of the charcoal, and when it all eventually passed through, I was feeling pretty good, because what I had now was completely clear and colorless, and it was as pure as it was gonna get.
Well, you could throw in some
What was
molecular
also really
sieves.
exciting was that when I put a few drops of it onto my alcohol refractometer and I looked inside, it told me that what I had was around 8% alcohol, which was honestly way better than I was expecting.
Congratulations, you could do a shot of
I
like a
mean,
beer.
it wasn't the super concentrated vodka that I was hoping to make when I started this project, and I guess what I made was more like a strong beer, but I was still really happy with it. The only concerning part was that when I did the final NMR, I saw that unfortunately, even after the distillation,
Still
it
methanol.
still had this little peak here that was not coming from ethanol. Instead, it was coming from a small amount of methanol, which is, of course, quite toxic. And what was really sad was that getting rid of it was going to be basically impossible.
Come
On
on.
top of
Be a
that,
good
with the methanol
moonshiner and just go
present,
blind by
it
drinking
did
it.
technically mean that the reading on my refractometer was a bit artificially high. And after doing a bunch of tests and calculations, I found that the true ethanol percent was likely around 7. Overall, though, I didn't really think that this was a huge deal, and with my air alcohol now finally
Again,
in hand,
translation,
I
I
was
don't
much
want to
more
deal with this
focused on
project any
something
further.
else,
It's
which
been
was
3 years
answering
and I
the
need to do
very
something
important
else.
question that had been on my mind for years.
What does air alcohol taste like? Is it good? Is it bad? I mean, I guess we'll find out.
It's probably bad.
Except, as I just mentioned, it did contain methanol, which is both toxic and extremely dangerous to ingest, and this was why I was only going to be tasting a very small amount. This way, there would be so little methanol that it would be totally safe, even if the entire amount that I was tasting was just pure methanol. However, I should say that technically this was still all at my own risk, and I don't recommend anyone trying anything like this.
But with that being said, I guess I just have to go ahead and try it. So, let's see.
Yep, that's alcohol.
It definitely tastes like alcohol, and it's definitely stronger than, a typical beer or something, but overall, it's actually pretty good. I mean, I personally am not the biggest fan of alcohol in general, so I'm probably, honestly, a terrible person to review this, but it's not bad.
With any
It
luck,
has
some
a
random
very
fruity
clean taste. There's
compounds are
basically
left over.
no real aftertaste
Oh.
or
Well, then it's nice and pure.
weird
Except for
taste
the
to
methanol.
it. I'd say it's pretty close to if I just put pure ethanol in water. But it does have a unique flavor. It does have
It does have
something
that
unique going
tiny
on.
bit of like
And,
super poison in there.
I think this is a really good result. I really need to scale this up. I need to figure out a
Yeah,
way
looks
to
can be
actually
deceiving, unfortunately.
make this scalable.
That bit of
to make a
methanol that
full
he showed
bottle
in
of
there,
this without the
that's a
methanol.
concerning
That would be
amount
really,
still. I would
really
not take a
interesting.
shot of that, a full shot of that.
So, with that being
Methanol
said,
is
that's
stupidly
exactly what I plan to
poisonous.
do next for
And it's so funny, the biological tangent for a second. It's very funny that the difference between, where'd I put my pen? A 1 carbon difference between methanol and ethanol, like, makes your body have, like, okay, this is a mild poison where I get drunk, versus this will kill me in, like, just a moderate dosage. Like, this is the difference between methanol and ethanol. It is 1 carbon with a couple hydrogens worth. That is the only difference between them. But in your body, the difference ends up being is that this gets I'm just gonna write body for short. This gets turned into, I believe, formic acid. Yeah, this gets turned into formic acid. Hold on. Uh-oh, drawing skills. Hello. This gets turned into formic acid, and then this gets turned into acetic acid. I'm pretty sure. And acetic acid is just vinegar. Your body can process that pretty easily. There's no real issues with it. Formic acid is a problem because this CH bond here is in a very, very unique space where, like, that's actually active. Like, that is a biologically active, like, kind of fragment of a molecule. And that is a decent reducing agent. So this hydrogen is going to try to donate itself to many things. And just that alone causes so many issues in biology because the body, like, biological oxidation reduction partially depends on formic acid to do that. So if methanol is turning into formic acid, that completely throws off your body's entire game of, like, oxidant versus reductant balance. And so, like, it starts just wreaking havoc on your systems. And it's literally just a difference of 1 carbon atom and 3 hydrogens that turn, actually, wait, sorry, 1 carbon atom and 2 hydrogen atoms that turn, haha, poison makes me drunk, to, oh god, poison kills me dead. It's so dumb. Biology's biology's dumb. It's a fake science. It's not real. But anyways, yeah.
Air Alcohol 2.0, and at the same time, I'll do my best to fix a bunch of issues with the current process. Like the fact that right now, my method of getting CO2 is an absolutely massive bottleneck, and it's both really inefficient and painfully slow to get even small amounts. Or like how in the setup, I have the gas flowing from the bottom of the reactor to the top, which I think is forcing the water and ethanol vapor to fight gravity and to get trapped inside and to mess things up. On top of that, I will very likely end up swapping out the catalyst for a much simpler one, which will probably be a lot less efficient, but I think I can counter that by just making a massive amount of it and by recycling the CO2.
Either way, though, I think that's about all I have to say about making air alcohol. But before I go, I feel like this is a good time to mention some of the other air related projects that I'm working on, like turning air into gasoline, air
Okay.
into a bomb, and air into diamond. On top of that, I should say that I'm getting pretty close to finishing some of the projects that I
Getting
started
as
years
much
ago,
value
like
from
making
the air
magnets from
around you as
scratch,
possible, huh?
spinnable carbon nanotubes, and liquid helium. Also, I think it goes without saying that all of these projects are both extremely time consuming and expensive, and this is why I'm very
Do shit like
thankful for
that, yeah.
all of our amazing YouTube.
All right, that's the YouTube member and sponsorship section, right? There's nothing else interesting if I click forward. No. Okay, cool. So, yep, that was air into alcohol. That was an interesting journey, and I cannot believe that he basically made a bench scale like pressure reactor to do this. And then he said that he had the audacity to say that was actually the easy part. And for me, a chemist, not a chemical engineer, that would be borderline impossible. I would not know where to start. But fully for him, he managed to do it, and then he, managed to get the catalyst together despite despite the crappy yield and disastrous synthesis. Um, and wouldn't you know it, he got ethanol from the air. Is it drinkable without poisoning yourself? No, but maybe we'll see a follow up video one day where it actually is. Um, yeah, I don't know. That's all I really have to say for tonight. I hope you all enjoyed watching along with me. And maybe I taught you a thing or two extra about, methanol versus ethanol in the body, or like this whole, you know, why having material interface with water for a while will cause it to become more crystalline over time, or what some of these other structures are, urea smiley face, some of the basic chemistry of like why hydroxide will turn into carbonate when you leave it out in the air for long enough. Shit like that is why I hope this is maybe better than just plain old reaction content. It has reaction plus a little bit of education in there. But I'm tired. That's gonna do it for me tonight. Thanks for watching. Be sure to, interact with the video, like it, comment it, tell me if you think I should keep doing these, to be honest. I'm a little bit unsure tonight. Yeah, I also have social media. I also have my Discord where you can log on in and talk about Mega Man and chemistry and stuff like that. I'll be back next week with more Mega Man Regenerus and Cave Story. Regenerus? That's not the title of the game. Mega Man Regenesis on Monday, Cave Story on Tuesday, and I'll see you around then. So have a good night, everyone, and talk to you later. Bye.